Good afternoon, one and all present here. Good afternoon, ma'am. Good afternoon, students. And today's AICTE Prerana class will be handled by Dr. Punita ma'am, Professor of ECE. And on behalf of Francis Xavier Engineering College, on behalf of AICTE Prerana Scheme, on behalf of Department of Electronics and Communication Engineering and my own behalf, I welcome Dr. Punita for the presentation. I welcome you, ma'am.
Thank you, sir.
So before we start the session, I request Jerlyn to host a prayer.
Prayer. Almighty God, we thank you for this wonderful day. Be with us throughout this day. We thank you, Lord, for the gift of education that you have given us. Help us to study well and get good marks. Grant us the strength to overcome temptations. Help us to be pure in thought, word, and deed. Bless all our faculty members and our parents. We ask all these in the name of the Lord Jesus Christ. Amen.
So I hand over the sessions to Dr. Punita ma'am, Professor EC,
Thank you, sir. Thank you so
MAM
much.
School of Engineering, Trichy.
Yes, sir. Thank you, sir. Good afternoon to another present over here. So today, I would like to thank you for the Suresh sir for giving me an opportunity to take a topic in a control system. So actually, what are the topics that what we are going to see on today is to be what about the basic control system components, and what about block diagrammatic representation, how to reduce the block diagram, what about open loop and closed loop feedback systems, and stability analysis, and how we'll be seeing the reduction of signal flow graph, and how we'll be determining the transfer function. What about transient and steady state analysis of LTI control system and frequency response? So these are all the topics that what we are going to see on today. So far we all know about the control system. So as of being to be on, so if it is to be an interactive, it will be well and good. So if you are hesitant to answer it, you can use your chat box and answer me. That's why I have not put a slideshow over here. Suppose if you are answering in chat box, I can able to get you. Okay. So now let me get into the topic. So first of all, we are in need to know what is meaning of a system and what is a control system. So before going into a system or control system, the first thing what we are going to see about them, what is an input over here. So we all know that what is the meaning of an input. That is the stimulus or an excitation which is applied to a system from an external source. Okay, so we'll be giving an we are forcing over to give over that in order to produce the output. Okay, that is the meaning of an input over here. So the technical word what you'll be seeing over here to be an excitation. Okay, so the stimulus or excitation which is applied to the control system. Alagu Sundar, please mute your mic. So next one, what is an output? Okay, so the actual response which is obtained from a system. So whatever we are giving the input over that. Alagu Sundar. Alagu Sundar, please mute your mic. Satish sir.
Ma'am, I will make him.
Yes, sir. Yes, sir.
I'll make him to meet is my.
Thank you, sir. So when we are defining an output, actually the actual response what we are obtained from the system, which is to be named as which is to be called as an output over here. Okay. The next what we'll be seeing over here, what is an system? Okay. The system when we are defining, it is an arrangement or a combination of different physical components which are connected in a manner to form an entire unit. So we'll be giving up an input over there. So by that input, by the application of an input, we'll be getting of an output over there. So that has to be connected in such a manner in order to get an entire unit. That is to be the objective of a system. Okay. So the next thing to be the, what is the meaning of control? So whenever we are having a system over on it, we have to monitor it, we have to regulate it, we have to direct it, we have to command it. Okay. So these are the terms which is used for defining the term control. Okay. So control means in order to regulate, direct or command a system so that the desired objective can be attained over here. So the objective of a system is that the entire unit has to be arranged in a manner in order to get an output based upon what we have given the input over on it. So all the systems which has to make we have to monitor over on it, or we have to regulate it, we have to direct it in order to attain our objective. So that is the meaning of your control over there. Okay. So by combining the system and control, that is to be named as a control system. So when you are defining a control system, it is an arrangement of different physical components connected in such a manner in order to regulate or direct or command itself in order to attain a specific objective. Okay. So this is about the control system. So the difference between the system and the control system is to be that, so system, whatever we are giving the input, we'll be obtaining the output over on it, but it may or may not be desired over on it. But in the case of a control system, so directly we can able to attain our objective by regulating or by monitoring over it. So a best example, what I given over here to be the, what is the difference between system and control system? So let me consider a fan over here. We know that the input supply voltage is around 230 volt to 50 hertz over here. So which is applying over, what will happen? So when you are applying our supply, so automatically the airflow will be over. Okay. So this is to be our system over there. But a fan cannot be a system. How is it so? So suppose even though if you are giving a supply, but there is no any airflow over on it, or if you are not getting any proper output or desired output, then that is not be a system. A fan without blades, simply we can say that. So it cannot be a system. So how it can be a system? So a fan with blades but without regulator. Okay. So suppose if you are switching on it, so it provides an output that is it's giving an airflow. Then it is to be named as a system. Okay. What is being a control system? So in order to direct the fan, in order to regulate a fan, in order to mount a fan, or we should have some switch control over on it. So probably what we'll be using over there. So we'll be using over here regulator. Okay. So if we are using a regulator, then it can be a control system. So a fan without blades cannot be a system. A fan with blades can be a system. Similarly, a fan with blades and a regulator can be a control system because it can provide a desired output, what we are going to have an attenuation. Okay. So now let me come back to the topic. So these are all the introduction about what is system, what is control system. So when you are saying about a classification of control system, we have two different types. One to be named as an open loop control system, and other one to be named as an closed loop control system. So what is an open loop? A system in which the control action is totally independent of output. So it is to be known as an open loop system. So see over the block diagram over there. So we will be giving a reference input which is given to an controller. That will be processed in order to get an output over there. So which is totally independent of output of a system is to be named as an open loop system. So best example, I'll be having a hand dryer. Do you know what function takes place in the case of an hand dryer? So actually the hot air will be comes out. Okay, as long as when you are keeping your machine over there. So how much your hand is dry? Okay, so it does the hand dryer function is to be that it it has to produce the output, whatever how much of your hand is dried or not. Okay, so it is completely independent of your output. The next example is to be a automatic washing machine. So the machine runs according to the preset time, irrespective of washing is complete or not. So just it is based on with respect to the timer how we are set over on it. The next example also we'll have a bread toaster. So the bread toaster, actually the machine will also run as per the adjusted time, irrespective of the toasting is completed or not. Okay. So this is to be an automatic tea or light switch, volume. Okay, so these are all the best examples in order to understand what is open loop closed system. Okay, what about the advantages? So advantages very simple in consideration. Because if you are setting an automatic washing machine, so what will be getting on it? So we can be setting up a timer. Okay, so it is to be economical. At the same time, open loop closed system, it is easy to maintain, generally stable, convenient to use as the output, which is difficult to measure over here. Okay. The next classification, I said you that closed loop system, but you have to know what are the disadvantages behind over it. So actually, they are inaccurate and unreliable because it doesn't know it doesn't know whether the bread toast has completely or not. Okay. So any changes in output cannot be corrected automatically. So these are all the major disadvantages in the case of an open loop control system. So the next loop, closed loop control system, a system in which the control action is somehow dependent on the output. So it should be dependent on the output. That is to be given as your closed loop system. Okay. So any best example for your closed loop system? Any example of closed loop system? So when you are saying about a closed loop, actually I said you that we should have a control over on it. Okay. So the block diagram, what does it say is that we'll be giving an input over that. Then the input is given to your controller and the plant so that the output will be here. So when we are making a control, any system, what we'll be requiring over here, Abdina, the main thing that is requiring to be the feedback. Okay. So we have to get the feedback from the output. And if there is any deviation between the input and the corrected output, then that is to be named as an error signal. So that has to be corrected until the entire output what we are given over on it. Okay. So that is to be the feedback path which is given over here. So the best example for an closed loop control system is an automatic electric ion. Okay. So the heating elements are controlled by output temperature of the ion. You can see over on it. Okay. The next to be what are all the advantages of closed loop control system? So actually, when we are comparing with the open loop, the closed loop control systems are even more accurate. And apart from that, the bandwidth range will be the large and it facilitates automation. Okay, the system is less affected by the noise over there, and sensitivity will be very small in order to make system more stable. And disadvantages of closed loop system is to be it is to be a costlier one, and it is complicated to design, and it required more maintenance. Feedback. So I said, the main part which is over here to be a feedback. That feedback leads to oscillatory response. Overall gain will be reduced due to the presence of feedback, and stability is the major problem because more care is needed to design a stable closed loop system. So you may expect a question of that. Which is to be the stable system, or which one to be the more accurate. Okay, so or you can have any examples of having of an electric ion or bread toaster, which is the example of your open loop or your closed loop system. Okay, so you can expect this type of 1-mark questions. Okay, and when you are saying about what is the difference between your open loop and what is a simple system? So when you are saying about an open loop control system, it is to be the simple and economical one, whereas their closed loop to be the complex and costlier. Okay, and open loop closed loop system which consumes less power, whereas your closed loop system will be consuming more power. Okay, so easier to construct is to be our open loop. When you are comparing with an open loop, closed loop are not easier to construct over on it because we'll be requiring more number of components over on it. and inaccurate and unreliable comes under your open loop, whereas closed loop systems are comparatively accurate and reliable with open loop system. And stability is not a major problem in the case of an open loop closed loop system, sorry, open loop control system. And similarly, whereas stability is a major problem in the case of an closed loop. Whereas the next to be the smaller bandwidth and will be having of an larger bandwidth, feedback element will not be present in the case of an open loop. So we know that there will be an feedback in the case of an closed loop system, and output measurement is not necessary because it does not depends on the output over in the case of an open loop, whereas the output will be necessary over that. Okay, and the best example for an open loop system are given over here to be coffee maker, automatic toaster, and a hand dryer. Whereas in the case of an closed loop, a temperature control of oven, servo voltage stabilizer, guided missile. The next thing what you have to know now, because we have to study the transfer function, right? So in order to study the transfer function, the basic thing what you have to know it about Laplace transform. Okay, so actually he is the French Newton Pierre Simon Laplace. He has developed mathematics in astronomy, physics, and statistics. He has begun work in calculus, which led to the Laplace transform over on it. Okay, so when we are saying about an Laplace transform, so in order to evaluate the performance of an automatic control system, that is a mathematical tool which is used to evaluate the performance of an automatic control system, which is to be named as an Laplace transform. Okay, so Laplace transform, what does it does? It converts the differential equation into an algebraic equation. And the usual notation, when you can able to remember it, actually we'll be using of an S. Okay, the S will be converted into time, that is t. Okay, and the Laplace transform exists for almost all signals of practical interest. So this is what we'll be doing over here. So in the case of Laplace transform, a time domain will be converted into an frequency domain. So we'll be solving a differential equation. Whereas in the case of an inverse Laplace, it is your frequency domain will be converted into an time domain over on it. Okay. Then what are all the advantages? So actually initial conditions which can be automatically incorporated. So a Laplace transform will provide an easy and effective solution when we are doing an automatic control system. And similarly, a Laplace transform which allows the use of graphical techniques over on it. Any idea about Laplace transform? What is Laplace transform f of t? Laplace transform of f of t. Where f of t can be defined as an Laplace transform of f of t. It can be defined as an integral 0 to infinity f of t e power minus st into dt. This is the standard notation. This is the standard formula for n when you are finding a Laplace transform of f of t. Okay, so Laplace L of f of t is equivalent to integral 0 to infinity f of t e power minus st into dt. Okay, so where your f of s is the, already I said you that the Laplace transform notation will be noted by means of an s over there. Okay, so f of s is the symbol for the Laplace transform, L is the Laplace transform operator, and f of t is the some function of time t. Okay, actually these are to be already actually we have to know all these things. So just for remembering the information, just I show the slide over here. So when you are finding the Laplace transform of 1, so the output will be equivalent to 1 by s. Okay, you can able to remember when you are taking a Laplace transform of 1 or an unit step signal u of t. So then the output is to be named as an 1 by s. Similarly, e power minus at, e power minus at. So the Laplace transform will be given as an 1 by s plus a, 1 by s plus a. Similarly, if you are founding for an e power at, then it will be equivalent to 1 by s minus a. Okay, e power. So if you are using of negative over here it should have a positive. If you are using a positive over there, then we'll be having of a negative. That is when you are finding a Laplace transform of e power at or e power minus a. Similarly, when you are finding for sine omega t, that is omega divided by s squared plus omega squared. So suppose if you are having a sine phi t, automatically what will be getting of அப்படின்னா 5 divided by s squared plus 5 squared or s squared plus 25. What is the omega value over on it? Okay. So the difference between a sine and cos to be a denominator will be the same. That is s squared plus omega squared. Instead of using omega in cos omega t, we'll be using of an s over there. Okay. Then after that, e power minus at sine omega t. So here actually we'll be having of a notation e power minus a. We know that sine omega to be omega divided by s plus omega square. And if you are using e power minus at, it is to be named as an 1 by s plus a. So wherever you are having a s, that has to be replaced by s plus a. The same case, similarly, if it is to be e power at sine omega t, then this will be s minus a the whole square. Okay. Similarly, for your e power minus at into cos omega t to be a s plus a. So instead of s, we'll be using of an s plus a. So s plus a the whole square plus omega square. Okay. And when you are finding the Laplace transform for t, the final answer will be 1 by s squared. Okay. Upper t squared na 1 by s cube. T power 3 na n factorial. Okay. We'll have a n factorial t power n. So for example, t square or t cube. So we'll be, what is the value of n over that? So 3 factorial. Okay. So you know that, right? Factorial. So for finding of n 3 factorial, 3 into 2 into 1. Okay. So you'll be having of an 6. Okay. 6 divided by s power 4. Okay. So this is the way to find out t and t power n. Similarly, if you are finding for n e power minus at into t power n, so we know that e power at is nothing but an s plus a. So it has to be replaced by n plus 1. Okay. So these are and apart last one to be our del of t. So we know that del of t stands for an impulse sequence. So the value of del of t value will be equivalent to 1 when you are finding the Laplace transform. So these are all the notations. So obviously how to know the answer blindly because we'll be giving the problems based on this values alone. Okay. So next one, inverse Laplace transform. So already I said you that we'll be converting convert an s domain back to your time domain over here. So in order to find the value of an f of t, so we'll be using over that to be an Laplace inverse of f of s. So already what we have over on it, we have your integral 0 to infinity f of t into dt. Okay. So if you are taking inverse, then you have to make use of over on it. The next when we are in need to define what is a transfer function. Okay. So transfer function states that it is the relationship between input and output of a system. It is defined as it is the relationship between input and output of a system is to be given by the transfer function. Okay. So definition for the transfer function: the ratio of Laplace transform of output to the Laplace transform of input under the assumption of zero initial condition. Because when we are finding the Laplace transform for derivative, we'll be getting initial solutions over on it. So we have to make an assumption that initial values to be equivalent to 0. Initial values to be equivalent to 0. So this is the apt definition of your Laplace transfer function. So this is to be see over there. So r of t to be your input, which is given to your system g of t. Then finally, what you'll be getting over there, c of t over here. Okay, r of t is an input which is given in time domain. So which is given to your system g of t. Then finally, we'll be getting the output to be your c of t. Okay. So when you are making when you are using or when you are finding the transfer function, we know that we have to take a Laplace transform for all the values. So what is the Laplace for r of t? So t domain has to be converted into time domain. Appa r of t will be converting into r of s. Okay. Similarly, what is the system g of t? So g of t will be converting into g of s. Then similarly, c of t will be converting into c of s. Okay. So what is scheduled for the transfer function? It is the ratio of Laplace transform of output to the input with a zero initial condition. Okay. So what is the Laplace transform of output c of t? Nothing but an c of s. Laplace transform of input is nothing but an r of s. So by making with an initial conditions to be 0 over here. So this is the way to find out your Laplace transform. Next, we have to see about and what about the transfer function of closed loop system. So already I said you that in the case of an closed loop system, we'll have a feedback element. Okay. So generally your input will be R of S, your output will be C of S. So in between that, we'll have a system over on it, which is to be connected in a manner. So the system will be defined as an G of S. So I said you that the output which is coming from the, so we have to get a feedback from the output. So this notation is to be named as an H of S. This notation is to be named as an H of S. Okay. 1 minute. Okay, so when we are seeing up over here, so we'll be getting the output over. So we have to find out what is E of S. What is E of S? That is to be our error signal. So we'll be having the output which is coming from the feedback signal is to be our B of S, and the input signal which is given over that. So the difference between these two signals, that is your R of S and B of S, will be given as an error signal. So from that, what is R of S? We can able to know that E of S plus B of S. Okay. So when you are finding a gain of your feedback network, actually H of S is equivalent to what is the input given? B of S, and your actually output by input. Input which is given over here to be C of S, and output what you are getting over here to be B of S. Okay. So the when you are finding the value of an B of S, so which is nothing but an H of S into C of S. So when you are finding a gain of a function, so G is nothing but an output C of S divided by R E of S. So we know that where C of S is equivalent to, so do the cross multiplication, G of S into E of S. So substitute the equation over here, that is here, C of S over here, G of S into R of S minus G of S into B of S. So again, from the equation 2 to 4, substitute the value of B of S. So by comparing these two equations, what that is this is the factor what we have to remember over there. So whenever you are having a closed loop feedback system, the transfer function is to be defined as an, or transfer function will be given by the expression G of S divided by 1 plus G of S into H of S. G of S divided by 1 plus G of S into H of S. So this is the transfer function of your closed loop system. Okay. Next one. What about the Laplace transform of passive element RLC? Because we know the passive element are to be R, L and C. Okay. So let me see the circuit elements. So what is the value of an R? What is the value of an R? So if you are taking a Laplace transform, then it is to be equivalent to R of this. Okay. So the next one. So when you are taking a Laplace transform of C, so actually your I of t is equivalent to C into dV by dt. So since we are finding for a voltage, so we have to take an integral over. So 1 by C of integral 0 to infinity I of t into dt. So which is nothing but an, when you are taking a Laplace transform, so the that is your capacitance V of S is equivalent to 1 by C into I of S divided by S, or 1 by SC into I of S. So when you are doing for an capacitance, so it is equivalent to 1 by SC into I of S. So resistance just as it is, R into I of t will be equivalent to here, R of R into S into I of S. Okay. So this is for your capacitor. So we'll be getting of an 1 by SC. Okay. Similarly, when you are doing for an Laplace transform for inductance. Okay. So D into I of t. So when you are making a Laplace transform, we'll be using the formula of an S into L into I of S. So V of S divided by I of S, which is equivalent to S into L over L. So Laplace transform for inductor value will be equivalent to S into L. So far is it clear? So far is it clear? Or a little bit any fast? If a little bit fast? See, somewhat you have to respond. Is it clear or not? So the next thing, we have to define the transfer function of RC and RLC circuit. Okay. So RC will be having of an RLC loop over on it. So we'll be applying our KVL loop over here. So we can write down the equation V I of t is equivalent to R into I of t plus 1 by C integral of I of t into dt. So what is the Laplace transform of R V I of t? So it is nothing but an V into I of s. Similarly, I of s. Okay, similarly, what about Ri of t? So it will be R of s. Okay. And what about 1 by C integral? So it will be equivalent to I of s divided by s. Okay. So we will be having only of an output alone. So output by input. Okay. So what will be getting? So V of s divided by C, V I of s equivalents to R into I of s plus 1 by SC into I of s over here. Okay. So we will be applying output voltage for output loop. So output loop when you are applying V naught of t is equivalents to 1 by C integral I of t into dt. So which is nothing but an 1 by SC into I of s. But what is the value of I of s? I of s is equivalents to SC into V naught of s. Now you substitute the equation value of 3 in the first equation. So what will happen? V I of s equivalents to. So you can take I of s to be common. So the expression will be R plus 1 by SC. Okay. So we can able to get the equation Vi by V naught of s is equivalents to. So Laplace transform nothing but an Laplace transform of output to the input. So V naught of s divided by V of s. So 1 by SC into SCR plus 1 divided by SC. So the entire thing will be getting cancelled. So we'll be getting the final expression V naught by Vi is equivalent to 1 by RCS, that is SCR plus 1. So next we have to see about an RC and RLC. So similar way you have to consider about an RLC. So when you are making an RLC, how will be applying a KVL loop? So we will be getting off an R into I of t plus L into di of t plus C into 1 by C into I of t into dt. Okay. So when you are applying all this equation, so we will be getting over here R into I plus L into I of s plus 1 by SC into I of s. So you take I of s to be common, you'll be getting the expression R plus SL plus 1 by SC over here. So then by cancelling all your equations, so your final expression will be 1 by SCR plus S squared LC plus 1. So this is the transfer function of an RLC circuit. Okay. Next, when order of a control system. Okay, so order is to be the highest power of S present in denominator. So let you consider an equation 1 divided by S plus 1. Let you consider an equation 1 divided by S plus 1. So what is the value in the case of a numerator? We'll have the value of 1. Similarly, what value is given in the case of a denominator? S plus 1. Upper S oda power n. What is the highest power of S present over on it? Okay. So what is the highest power of S is there? S is to be 1. Okay. Appa on the order of a system which is to be given as an 1. Okay. So for example, 1 divided by S squared plus 2S plus 1. What can be the order now? The order can be equivalent to 2. Okay. So what is the highest power of S present in the denominator? Highest power of S present in the denominator. Okay. Now determine the order for the given system. What is the order of the given system? Please use your chat box and answer me. What is the order for the given system? Out of 71, any one can answer. What is the order of the given system? Make it fast. What is the order of the given system? Anyone respond, please? What is the order? Can you able to understand what is the order of a system? Actually, order is to be defined as the highest power of denominator in the value of an s. What is the highest power of denominator in the value of s? Which is to be given as 4. Very good. Thank you for your response. Good. This is what I am expecting. So the highest power of s in the denominator is to be 4 over here. So the order of a given system is to be 4. Okay. So next one, what is meaning of an proper system? What is the meaning of an proper system? Okay, a proper system is a system where the degree of the denominator is larger than or equal to the degree of a numerator polynomial. Where the degree of a denominator is larger than or equal to the degree of a numerator polynomial. So see over here. So when you are seeing up here, s plus 5 into s plus 2, s into s plus 3 into s plus 4. Okay. Can you able to determine what is the order of a given system? Can you able to determine what is the order of the given system? Answer B. What is the order of the given system? See whether it is to be right or wrong. Just to try. At least even one can respond, then I can able to deliver it. What is the order of the given system? Three. Good. So see over here. So in order to obtain the highest power of denominator, so we cannot say that actually the highest power of s is to be 1. Not like that. Okay. We have to simplify. We have to multiply the and we have to find out the final complete expression value. Okay. So when you are multiplying over here, what will be your value? So s plus 3 into s plus 4 will be getting of an s squared plus 7s plus 12. Similarly, when you are multiplying over here, so we'll be getting of an s cube plus 7s plus 12s. Okay. So the highest power of equation in denominator of a given system is to be 3. Okay. So it is to be our third order system. Okay. So the degree of denominator is larger than the numerator. What about the numerator value? The numerator value is given as an we'll be getting of an 5s plus 2s plus 10. Okay, upper s squared plus 7s plus 10 will be a numerator. Upper the denominator is larger than the numerator. Then we are defining that system is to be our proper system. Okay. So far is it clear? I think so. Okay. Okay. So when we are similarly determining the order of the given system, so obviously the order of the given system is to be our the highest power which is given to be our 5 over here, because s cube is squared plus 12s plus 5. So when you are multiplying over here, 7s power 5. Okay. So again, this is to be also a proper system. Okay. Then now we have so far what we have seen. What about a type of a system? What about the types of system? Sorry. What about the order of a system? Okay. So the next thing, what you are going to see about now, what about your type of a system? Types of system. So we'll have a zero order system, first order system, second one to be the second order system. So let me see one by one. What about zero order system? Okay. So if the highest power of complex variable s present in characteristic equation is 0, then it is called zero order system. So see your expression. See over here. So characteristic equation is nothing but here a denominator value. Okay, a denominator. So when you are seeing up here unity feedback system. So before that I have to say what is unity feedback system. ஸோ உங்களோட கண்ட்ரோல் சிஸ்டம்ல சொன்னேன் தெரியுமா உங்களுக்கு, சிஎஃப்எஸ்ல இருந்து ஒரு ஹெச்எஃப்எஸ்னு ஒரு ஃபீட்பேக் சிஸ்டம் சொல்லுவோம் இல்லையா, அந்த வேல்யூ வந்து if it is to be 1 and then we can be name it as an unity feedback system. ஓகேவா? அப்ப வெறும் உங்களோட சிஸ்டமோட வேல்யூ g of s மட்டும் வரும். ஃபார் எக்ஸாம்பிள், if you are finding the value of an cfs divided by rfs, cfs divided by rfs பண்ணீங்கன்னா என்ன வரும் உங்களுக்கு, g of s, அதாவது க்ளோஸ் லூப் சிஸ்டம் பார்க்கும்போது g of s divided by 1 plus g of s into h of s னு வரும். கரெக்ட்டா? g of s divided by 1 plus g of s into h of s னு வரும். So since the h of s to be a unity feedback system, அப்ப g of s divided by 1 plus g of s னு வரும். ஓகேவா? Similarly, when you are proceeding over here, so zero order system அப்படிங்கும்போது உங்களோட characteristic equationsல உங்களோட highest power of s வந்து 0வா இருந்தது அப்படின்னா then the given system is to be a zero order system. So practical example I have given over here, amplifier type control system. Okay va? Adhe madri then we go for the first order. So if you're going for the first order, what will be getting over there? So if the characteristic equation is 1, adavadhu ipo keela parunga 1 by 1 plus scr nu irukku, what is the power of s over on it? The power of s is equivalent to 1. Then that is to be named as an first order system. See over here a characteristic equation. This is your denominator part la enna irukko adudha vandu you will be writing the idume neenga vandu you can be expecting write down the characteristic equations for the given system abdina denominator la enna irukko that has to be equivalent to 0. Okay, so this is about your first order system. So the example what I given over here to be RC circuit and thermal type system. Okay, next one to be your second order system. So if the characteristic equation is 2, so see over here s squared LC plus sRC plus 1. So the highest degree polynomial which is given over here to be 2. So then that is to be named as an second order system. So the best example for your second order to be your RLC circuits, robotic control systems. Okay. Okay. The next one we have to see about an block diagram algebra. So far what we have seen over at Abdina, we have seen what is a system, what is a control system, what about the different types of control system, then how to define the transfer function. So for defining a transfer function, how the Laplace transform helps for us, okay, and how to find the order of a system, and what about the types of a system. Okay, the next we have to see about an block diagram algebra. Okay, so if the system is simple and it has a limited parameters, then we can able to analyze the system by means of an transfer function. So what is transfer function? It is defined as the ratio of Laplace transform of output to the Laplace transform of input under zero initial condition. Okay, so if it is to be a simple abdina, we can use the method that is a transfer function. Okay, if the system is complicated and if you are having the number of parameters, then obviously it will be very difficult to analyze it. Okay, so in order to overcome this problem, the block diagram representation method is used over here. Okay, so it is a simple way which represents any practically complicated system. Okay, so in this each component of a system is represented by a separate block. We'll have a separate block. So all the block which is to be named as an functional block. Okay, so these blocks are interconnected in a proper sequence over there. Okay, now let me see what is a block diagram. So the block diagram is to be the pictorial representation which will be consisting of several blocks over on it. Okay, so it is a shorthand pictorial representation of the cause and effect relationship between input and output of a physical system. So we'll be giving us in a separate blocks over on it. So this is the output over here. This is the output. So output in y of s what it will be abdina. So we will be multiplying with the system or the value which has to be multiplied with the input value. Okay, so what about your y of s? Y of s is equivalent to x of s into 3 of s, or 3s into x of s. So multiplication of the system value and your input. Okay, so the next fundamental is to be a summing point. summing point என்ன சொல்லுவோம் நம்ம, we have to make an addition or we have to similarly here இங்க வந்து என்னன்னா the summing point can be act as either an addition or an subtraction. இப்ப see over here, this is your summing point symbol. We are giving a input x, y and z. ஓகேவா? இந்த x ஓட symbol பாத்தீங்கன்னா plus, y ஓட symbol பாத்தீங்கன்னா plus, z ஓட symbol பாத்தீங்கன்னா minus. Okay, so combinedly we are getting the output. Upper we are giving a 3 different inputs. One input x is positive, so x will be positive, y will be positive and z will be negative. Upper in the summing point order output என்னன்னா x plus y minus z. X plus y minus z. That is why we are said now summing point is 2 or more signals that can be added or subtracted at a summing point. The next block to be a take-off point. The next block to be a take-off point. In the take-off point, output signal can be applied to 2 or more points from a take-off point. Let's apply it. So, this is the take-off value. Okay. Next one, forward path. Feedback path. That is forward path which will be we can say which will be carried out from the input to an output. Direct ஒரே வழியில அப்படியே போயிட்டே இருக்கு. Feedback pathங்கிறது outputல இருந்து மறுபடியும் reverse எடுத்து input join பண்றது. Okay, so the direction of flow of signal from input to output which is to be named as an forward path, whereas the case of an feedback path, so the direction of flow of signal from output to input, which is to be named as an feedback path. Okay, so we'll have several rules and regulations in order to reduce your block diagram, in order to have the reduction of a block diagram. Okay, so first rule is to be your cascade. Cascade, that is to be the multiplication. Okay, so whatever we'll be having the blocks in between over on it. So for example, see over here, R of S is to be the input, which is giving to your G1, which is giving to be your G1. The output which is given over on it to be your R1 of S. Okay, and then we'll be getting to your G2. So finally, we'll be getting the output of your C of S. So when you are combining these two things, so what will be getting over there? By multiplying two values, that is your G1 and G2. By multiplying your G1 and G2, so the output C of S is equivalent to your input and your that is your G1, G2 into your R of S. G1, G2 and your R of S. Okay, so this is about your cascade. The next one, so when you are combining 3 inputs or when you are combining your 4 inputs, G1, G2, G3. Okay, so this will be cascading into a single block. So we'll have a separate blocks G1, G2, G3. So the equivalent value of this to be our G1, G2, G3, which will be combined as a single block over it. So this is our first rule. Okay, see over here. So R of S is given G1 and G2, but in between that you will be getting an output, some value R1 of S, and again you'll have a G of 3. But you should not make it as combined as an G1, G2, G3. So you should not do like that because you'll have an intermediate block over on it. So the output equivalent, see over here, this is the output equivalent. G1 and G2 can be in cascade. Okay, so this will be a separate one which is given over here to be G3 into your C of S. Okay. So next one, how will be connected in parallel? How will be connected in your parallel cases? Okay. So in the case of an parallel, see over there. So what will be getting? G1 and named as an, this point is to be named as an summing point. So where here R1 of S is to be added, R2 of S is to be R minus, and R3 of S is to be R added over here. Okay, so where this is to be your input, that is here. So output what you are getting, C1 of S. Similarly, the output here to be our R2 of S, and similarly this is to be our R3 of S. Okay, so the combined block, that is your parallel block, how we will be combining abdina, the output which is given over here to be G1 minus G2 plus CR G3. So this is the way to combining your parallel blocks. Okay, G1 minus G2 plus G3. Okay, so in cascade we'll be using of an multiplication, whereas in the case of an parallel, that has to be added over on it. Okay. The next one, how to eliminate your feedback loop. How to eliminate your feedback loop. Now feedback loop நான் உங்களுக்கு already சொல்லிட்டேன். இது வந்து நம்ம transfer function derive பண்ணோம் இல்லையா? That is the simplified answer over here. Okay. So நம்ம என்ன அதாவது இங்க என்னன்னா இங்க G நான் mention here. இங்க வந்து G of S. So G of S into H of S. G of S into H of S. அதுவே வந்து உங்களோட feedback loopல வந்து if it is to be given that unity feedback loop system. If it is to be given that unity feedback loop system அப்படின்னு கொடுத்தாங்கன்னா அப்போ what will be our expression? It is to be noted at G of S divided by 1 plus or minus G of S. Okay. Because H of S to be a value to be 1. Okay. It is an important rule. Whenever you are doing the block diagram reduction, it plays this rule plays an important role. Next one, okay, இது வந்து negative feedback. Okay va? So we'll have a negative feedback and positive feedback. Negative feedback இருந்தா we'll be getting over on your plus and positive feedback to be your minus 1. Okay, so இது வந்து I think so. So positive feedback it is to be a minus 1. Negative feedback it is to be your plus 1. Okay, சரி. Next rule பாத்தீங்க அப்படின்னா associative law for summing point. Associative law for summing point. அதாவது என்ன அப்படின்னா the summing point, that is the order of the summing point can be changed if they are connected in series. If they are connected in series, the order can be changed over there. Okay, so what will be getting over here? See, this is the value of your B1. This is the value of your B2. So whenever what is the output of this expression? அப்ப இதோட expression பாத்தீங்கன்னா R of S minus B1. ஏன்னா இது வந்து இது ஒரு summing point உங்களுக்கு. ஓகேவா? So R of S minus B1 இதோட output எங்க போகுது உங்களுக்கு? X. So Xங்கிறது என்னது உங்களுக்கு? R of S minus B1. So இங்க symbol வந்து it is not given over here. Let me consider this to be a negative one. So R of S minus B1 minus B2. அப்ப நான் என்ன பண்றேன்? இந்த summing point B2 வந்து I have interchanged over here and hitting over here. அப்ப இந்த X ஓட value என்ன வரும் எனக்கு? R of S minus B2. R of S minus B2. அதே மாதிரி இங்க என்ன input feed பண்ணிருக்கேன்? Minus B1. அப்ப C of S ஓட value என்ன வரும் எனக்கு? R of S minus B1 minus B2. So when you are comparing these two, so there is no any change we can able to observe it. Okay. So that is why you can interchange the summing point. You can interchange the summing point if it is connected in series. அதாவது இப்ப நடுவுல வந்து ஒரு சிஸ்டம் இருக்குன்னு வெச்சுக்கோங்க. நீங்க அப்ப மாத்த முடியாது. சரியா? இது ரெண்டும் சீரிஸா கனெக்ட் ஆயிருக்கும்போது மட்டும்தான் you can able to do the you can able to change the order of your summation value. Next rule பாத்தீங்க அப்படின்னா shift the summing point before the block. Shift the summing point before the block. Okay. So எப்படி summing point before the block பண்றோம்? இப்போ இதுதான் உங்களோடது. இது வந்து summing point. இது வந்து block. Okay. So what is the output over here? இங்க என்ன output வரும் உங்களுக்கு? R of S into G. கரெக்ட்டா? So R of S into G. So இங்க என்ன கொடுக்கிறோம் நாம உங்களுக்கு? X கொடுக்கிறோம் உங்களுக்கு. அப்ப R of S into G plus X. இதோட output என்ன உங்களுக்கு? C of S. ஓகேவா? இப்போ நான் என்ன பண்றேன்? இந்த பிளாக்குக்கு அதாவது shift the summing point before the block. I am shifting my summing point before the block. அப்ப நான் இங்க மூவ் பண்ணேனா this is my block over here. அப்ப R of S வந்துரும், X வந்துரும். ஆனா I have to get over here R of S into G. கரெக்ட்டா? அப்ப நீங்க என்ன பண்ணனும்னா when you are shifting up the summing point before the block, you have to add the block, one more block which is to be named as an 1 by G. Add block 1 by G. Okay. Appa what will be getting over here? So we will be getting of an R of S plus X divided by G varum. Correct? R of S plus X divided by G. Okay. Appa cross multiply பண்ணீங்கன்னா என்ன ஆகும்? G R of S plus X. G R of S plus X. So appa both are to be equal. அப்ப summing point block க்கு முன்னாடி மூவ் பண்ணீங்கன்னா you have to multiply by the gain factor 1 by G. Okay, not a gain factor, but multiply by a factor 1 by G. Okay, your next rule. shift the summing point after the block. அதாவது summing point பிளாக்குக்கு அப்புறம் நான் மல்டிப்ளை பண்றேன். பண்ணும்போது என்ன பண்றேன்னா you have to multiply by g. So before na 1 by g, after na g. Okay. Next, இதுதான் டேக் ஆஃப் பாயிண்ட் சொன்னேன் இல்லையா உங்களுக்கு. ஸோ அந்த நம்ம போய் which is flowing over through on it will be taking the value of an x. Okay. Shifting a take off point before the block. அதாவது இந்த x நான் முன்னாடி கொண்டு வர போறேன். முன்னாடி கொண்டு வந்தீங்கன்னா என்ன ஆகும்? The thing is to be that I have to get the value of an இங்க வந்து பாத்தீங்கன்னா g into r of s ங்கிறது உங்களோட அவுட்புட். கரெக்ட்டா? இப்போ அதே மாதிரி நான் இதை இங்க கொண்டு வந்துட்டேன்னா gங்கிற ஃபேக்டர் எதுவுமே கிடையாது. So I have to multiply by the value of g. Before கொண்டு வந்தா என்ன பண்ணணும்னா you have to multiply by g. அப்ப after கொண்டு போனீங்கன்னா என்ன பண்ணுவீங்க நீங்க? What will be doing after the point? So it will be considered as an 1 by g. நம்ம summing point-க்கும் take off point-க்கும் இதான் டிஃபரன்ஸ். ஓகேவா? So அங்க வந்து summing point before the block பண்ணும்போது 1 by g பண்ணுவோம். After பண்ணும்போது வெறும் g ஆல பண்ணுவோம். Whereas in the case of an take off point பண்ணும்போது முன்னாடி பண்ணும்போது just will be multiplying with the factor g. அதே after block பண்ணும்போது it will be multiplied by 1 by g. ஓகேவா? So this is about your block diagram reduction technique. அதாவது என்ன சொல்றோம் அப்படின்னா while solving a block diagram for getting a single block equivalent, okay, we have to apply all the rules over here. Okay. So இது block diagram reduction பொறுத்த வரைக்கும் என்ன அப்படின்னா யார் டெசிஷன் பிளேஸ் a major role. இப்போ என்னன்னு கேட்டீங்கன்னா இப்போ நான் வந்து திங்க் பண்ணும்போது I will be thinking of that first let me cascade the blocks and then I will be moving for shifting my summing point before the block. But you may have a decision that shifting a summing point before the block and we'll have a cascade. So அது வந்து நீங்க அதை கரெக்டா ஃபாலோ பண்ணி we have to do over here. Okay. ஓகே. அப்ப நம்ம எதுக்கு ப்ரிஃபரன்ஸ் கொடுக்கணும்? சோ ஃபர்ஸ்ட் ப்ரிஃபரன்ஸ் கோ ஃபார் your சீரிஸ். எங்கெல்லாம் சீரிஸ் காம்பினேஷன் இருக்கோ சோ அதுக்கு வந்து ஃபர்ஸ்ட் ப்ரிஃபரன்ஸ் கொடுங்க. செகண்ட் ப்ரிஃபரன்ஸ் வந்து கோ ஃபார் த parallel blocks. ஓகே. தேர்ட் ப்ரிஃபரன்ஸ் கோ ஃபார் your feedback loop. So this is the preference which has to be given over here. So fourth rule வந்து this is to be the equal preference. அதாவது எப்படி வேணா நீ கொடுத்துக்கலாம். summing point before or after block பண்ணிக்கலாம் இல்ல adjust summing point பண்ணிக்கலாம், shifting the take off point பண்ணிக்கலாம். சரியா? So these are the this is the thing which has to be take over here. So this is your example sum. Okay. 2 minutes break. I'll join you. Okay, let me see our block diagram reduction. See the blocks. So far, I think so. You can able to remember what are the rules that I have said over here, right? That is, we can able to combine in cascade. We can able to combine the blocks in parallel. We can able to combine the blocks in feedback. We can eliminate a feedback loop, and we can interchange the summing point. And then we can shift a summing point before the block, after the block. Similarly, we can now have a takeoff point before the block or after the block. Okay. Can anyone start? What can be the first rule which apply over here? Make it fast. See over here and think of it. So which is to be the cascade, which is to be the parallel? Any idea? Not it. See over here, first when I said you that the first preference goes for your series blocks. See over here, is there any series blocks over on it? Either and series blocks we'll have an intermediate over here. So either with I think so far I don't have any series blocks over here. Okay, ma? So I cannot able to apply my rule 1 over here. And second thing, we will be going for an parallel blocks. Parallel blocks irkapa? Answer me. Can you able to see any of your parallel blocks? What are all the parallel blocks? If can you able to see what are all the parallel blocks over here? Is it present or not? Good. Yeah, G3, G4, G5 or to be our parallel blocks. G3, G4, G5 or to be the parallel blocks. See over here, everything is coming point over here. We'll be combining all these blocks into one single block. Okay, so that will be doing over here. So parallel blocks varumbodhu, I said you that cascade na multiplication, parallel na enadhu addition symbol over here. See G3 plus G4 plus G5. Okay, good. Appa ida combine பண்ணிடுவோம் நம்ம. கரெக்ட்டா? அப்ப இந்த இடத்துல G2 இருக்கு. அப்ப what rule will be applying over on it? பலர் நீங்களே ஆன்சர் பண்ணிருங்க. Then it will be interesting. So when you are saying over here G3 plus G4 plus G5, okay? So this will be having over here. Appa what can be this one next one? What rule will be applying over here? ஒரே ஒரு எக்ஸாம்பிள் தான் வச்சிருக்கேன். I don't have much examples. Out of 77, even one cannot answer it. Why so? Everyone are in sleepy mode. See over here. அப்ப இதே என்ன ரூல் இது நமக்கு என்ன தெரியும் உங்களுக்கு? So this rule is to be named as an combining our cascade block. Okay, so when you are combining of this cascade block, what will be getting over here? அப்ப G2 into G3 plus G4 plus G5. Correct? So we'll be getting of your G2 of G3 plus G4 plus G5. Okay, now the next will be applying for the elimination of your feedback loop. This is the elimination of your feedback loop. Output inga varudhu. So we'll be taking the part of the output which is fed from over here and which is given the value to be our H1. Okay, ba? What is the output of this block? What is the output of this block? Elimination of feedback loop la enna varum ungalku? G divided by 1 plus G into H. So inga G irukadla enna irukku ungalku? G1 into 1 by 1 plus G1 into H1. Okay, ba? So let me see the next one. See here, G1 divided by 1 plus G1 into H1. Now again, what is this combining over here? So everything has combined, which now we have to apply the rule of an cascade block. Upper G1 divided by 1 plus G1 into H1 into of G2 of G3 plus G4 plus G5. See over here. Now again, this will be placed over here. Feedback loop. Feedback loop enna பண்ணுவீங்க நீங்க? இந்த H2 மேல கொண்டு வந்துருவீங்க. கரெக்ட்டா? H2 மேல கொண்டு வந்துருங்க. Divided by 1 plus இது value இது G1 G2 of G3 plus G4 plus G5 divided by 1 plus G1 H1 into H2 கொண்டு வருவீங்க. Then again we are do the cross multiplication. Both the denominator will be getting cancelled. And after simplifying it, you will be getting the final expression to be this one. G1 G2 of G3 plus G4 plus G5. Divided by 1 plus G1 into H1 plus G1 G2 H2 of G3 plus G4 plus G5. Then again, this has to be combined with G6. So now again, this block which is also to be in a series one. So final answer pathing in this is to be a final answer. G1, G2, G6 of G3 plus G4 plus G5 divided by 1 plus G1 into H1 plus H1 G1 G2 H2 of G3 plus G4 plus G5. Okay, so this is the way to reduce your block diagram. This is the way to reduce your block diagram. அப்ப நீங்க வந்து what you have to remember in the case of an block diagram algebra அப்படின்னா, the first preference has to go for if the blocks are connected in series or in cascade form. Second preference has to given for if the blocks are connected in parallel form. Third one, we have to eliminate our feedback loop. Okay, so the next equal weightage can be given for all the, that is if you are interchanging any summing point, or if you shifting the takeoff point or a summing point before the block or after the block. Okay, so these are all the informations that you have to recollect while you are doing the reduction of an block diagram algebra. Okay, the next we have to see about our, okay, this is your answer. The next one to be a signal flow graph. So the alternate method to the block diagram representation, the flow graph which was developed by Samuel Jefferson Marshall. Okay, so when you are saying about your signal flow graph, it provides the relation between a system variable but without requiring any reduction procedures. So we don't have any reduction procedures in order to use of your signal flow graph. Okay. So a simple equation, see over here. So this is your equation, y is equivalent to a into x. இங்க a-ங்கிறது என்னன்னா scaling factor, y-ங்கிறது output, x-ங்கிறது input. So the signal flow graph representation பார்க்கணும். Direction is more important over here. Okay. So when you are replacing, when you are giving your x to y, so the scaling factor is multiplied by a. Okay வா? So இதுதான் உங்களோட signal flow graph representation. Okay. So what are all the important terminologies that what we'll be using over here? The first one to be named as a branch. So branch na enna, the line which is joining the nodes. Actually nodes ங்கிறது முதல்ல என்னன்னு தெரிஞ்சுக்கோங்க. Nodes ங்கிறது என்ன அப்படின்னா your x and y are to be your nodes. X and y are to be your nodes. இப்போ இந்த x and y ங்கிற nodes join பண்ற line தான் என்ன அப்படின்னு கேட்டீங்கன்னா branch. So I represent it over here. Okay. The next to be your dummy nodes. Dummy nodes ங்கிறது என்ன உங்களுக்கு? That is a branch having one can be added at input as well as output. Okay. So ஒரு one multiply பண்றதுனால actually இதுதான் உங்களோட expression. இந்த expressionோட ஒரு one add பண்றதுனால you don't have you doesn't get much change over on it. Okay. So அந்த nodes பேர் தான் என்ன அப்படின்னா, which is to be named as an dummy nodes. Which is to be named as an dummy nodes. See over here. Okay. So next to be our next terminology. What is meaning of an input node? Input node na enna ungalke theriyum. Enna solluvom nama ulla edu varudho, which is only which has only outgoing branches. Adhaavadhu velila poradhukku mattum. Okay va. Adhe madri output node. Output node ங்கிறது என்ன உங்களுக்கு? Which has only incoming branches. அதாவது இந்த direction representations இருக்கும். Okay வா? Towards outside or towards inside. Okay. So that is to be named as an input node and your output node. See this x naught இருக்கு இல்லையா? இந்த x naught அப்படிங்கிறது என்னது உங்களுக்கு? Input node, because it has your outgoing branches. So அதே மாதிரி உங்களோட output nodeங்கிறது இங்க x4. This to be your incoming branches. Okay. Next one பாத்தீங்க அப்படின்னா forward path. So forward path already நான் சொல்லிட்டேன் உங்களுக்கு. அதாவது feedback path, forward path சொல்லிருக்கேன். Forward pathங்கிறது என்னது? Which flows from input to output. Which flows from input to output. So see over here, இப்போ வந்து ஒரு signal flow graph நான் வரைஞ்சிருக்கேன். R of S ல இருந்து, அதாவது இப்போ இதுல எத்தனை நோட்ஸ் இருக்குன்னு பாத்தீங்கன்னா 1 அந்த சர்க்கிள் மார்க் பண்ணிருக்கோம் இல்லையா? 1 2 3 4 5 6 7 இருக்கு. ஆனா இதுல இன்புட் அண்ட் அவுட்புட் பாத்தீங்க அப்படின்னா R of S and C of S. Okay va? So இப்போ when you are writing a forward path பார்த்துக்கோங்க, அதாவது ஒரே டைரக்ஷன்ல மூவ் ஆகணும். அப்ப இங்க இருந்து எங்க மூவ் ஆகுது உங்களுக்கு r of s வந்து அடுத்த நோடுக்கு போகுது. எது மூலமா? which has been forwarded which has been traveled by g1 of s. அடுத்து அதே டைரக்ஷன் போகுதா? g2 of s. Then again next to be as g3 of s. Then next to be as g1, g2, g3, g4, g5. So after it is to be a G5. See over here. Actually வந்து இங்க G4 ல இருந்து so இதுல forward path பாத்தீங்கன்னா ஒரே ஒரு forward path கிடையாது. I think we'll have a several forward path. One forward path பாத்தீங்கன்னா G1, G2, G3, G4, G5 and G7. Next forward path பாத்தீங்கன்னா G1, G2, G3, G4, G6 and G7. Okay. See over here. So when you are seeing up here, next one, okay. Next loop, this is about your forward path. Okay. Next வந்து என்னன்னு கேட்டீங்கன்னா loop. லூப்ங்கிறது என்னன்னா ஒரு closed path, அதாவது ஒரு நோடுல ஆரம்பிச்சு which has to be end with the same node. Starting from the node which has to be end with the same node. That is to be named as a loop. அதாவது we can be named as a closed loop. Okay va? So see over here அந்த ரெட் கலர்ல மார்க் பண்ணிக்கோங்க. Which is to be இப்ப இங்க இந்த நோட்ல இருந்து ஸ்டார்ட் ஆகுது. Again this goes over here. அதுல இருந்து ஒரு feedback எடுத்து it ends up over there. Okay, this is to be named as your feedback loop. Okay, so first loop என்ன வருது உங்களுக்கு? G2 of s into, அதாவது you have to multiply the system and your transfer function. So in see the first output of your loop G2 into H1 of s. G2 of s into H1 of s. Similarly, the next one to be our G4 of s into G4 of s into H2 of s. அடுத்த loop பாத்தீங்கன்னா actually இந்த டைரக்டா இதுல போகாம it goes over here G5. So when you are seeing over here, so this will be your third one. See over here G4, G5 and then H3 of s. Okay, so this is about your loop. Next feedback loop, அதாவது என்னன்னா சேம் நோட் ஒரே ஒரு லூப் மட்டும் இப்ப சுத்தி, அதாவது இப்ப லாஸ்ட்ல பாத்தீங்கன்னா இப்ப G1 ல இருந்து G2 போயிட்டு மறுபடியும் அதுக்கப்புறம் G1 வந்தது. ஆனா இது எப்படின்னா G1 ல இருந்து G1 இல்ல G2 ல இருந்து G2 செல்ஃப் நோடு. ஓகேவா? So it is to be named as a self loop. See over here, this is starting from the x1 and then again so it will be ending up with your the same loop. Then it is to be named as your self loop over here. Okay. Next one, this is to be our loop gain எப்படி கண்டுபிடிக்கிறதுன்னு பாருங்க. Loop okay, and then self loop okay, and then loop gainங்கிறது நீங்க அங்க என்ன factors இருக்கோ, அதாவது for example see over here, this will be multiplied with a32 and a23. This is to be your loop gain. நெக்ஸ்ட் வந்து ஃபீட்பேக் பாத் லூப். ஸோ ஃபீட்பேக்ங்கிறது உங்களுக்கு தெரியும், அவுட்புட்ல இருந்து we have to take over from the which is given over here input. இப்போ இதுல பாத்தீங்கன்னா see over it ஆக்சுவலா x7 ல இருந்து x6 க்கு போகுது, x6 ல இருந்து x5 போகுது, x5 ல இருந்து x4 போகுது, x4 ல இருந்து x3 போகுது, then again x3 to x2. ஓகேவா? ஸோ ஆக்சுவலா இது வந்து normal flow உங்களுக்கு இங்க. So apart from that, see over here the function which is given over here to be A12. Okay. And then touching loops. Touching loops பாத்தீங்க அப்படின்னா ரெண்டு இண்டிவிஜுவல் லூப் எடுத்துக்கோங்க. ஃபார் எக்ஸாம்பிள் இப்ப இது ஒரு இண்டிவிஜுவல் லூப், அதாவது H2 G2ங்கிறது ஒரு லூப், G3 H3ங்கிறது ஒரு லூப். இந்த ரெண்டு லூப்பையும் நீங்க டச் பண்ணீங்க, அதாவது if it is able to touch over there அப்படின்னா it is to be named as a touching loop. So அது ரெண்டும் ஆகல அப்படின்னா then that is to be named as a non-touching loop. Okay, so this is the best example of I have shown over here. So this is the case of a non-touching loop. Okay, when the loops are not having any common node between them, so they don't have any common node, then that is to be named as a non-touching loop. So when you are seeing up here, இது வந்து பாத்தீங்கன்னா incoming, அதாவது incomingங்கிறது towards the inner side. Okay, so incoming branches இருக்கு. At the same time we'll be having of an outgoing branches, so it is moving towards an outgoing node over there. Signal flow graph ஓட major important பாத்தீங்க அப்படின்னா which is to be named as யார் Mason's rule. Okay வா, so due to his name, the rule ஓட name என்ன பண்ணிருக்காங்க அப்படின்னா, so in order to arrive the system transfer function, the Mason's which has given the formula which is to be named as an Mason's formula. So உங்களோட transfer function C of S divided by R of S, C of S divided by R of S ஓட formula என்னன்னு பாருங்க, which is equivalence to summation I is equivalence to 1 to n Pi del I divided by del. Summation I is equivalence to 1 to n Pi del I divided by del. Okay, so what about the value of an Ni? So what about the value of an n? N-ங்கிறது number of forward path. So நம்ம பார்த்தோம் இல்லையா, which is flowing from input to the output. Okay, so that is to be named as a number of forward path, where Pi stands for an ith forward gain. அதாவது what is the P1 P2, so அது நம்ம கண்டுபிடிக்கிறது தான் வந்து என்னன்னா, so நீங்க எத்தனை forward path கண்டுபிடிச்சிங்களோ, for example உங்களோட signal flow graphல ஒரு 3 forward path இருக்குன்னு வெச்சுக்கோங்களேன், அப்ப 3 forward path ஓட gain தான் என்னன்னா ith forward gain. So if you are having an I forward path, then we will be getting over I forward gain. Okay, so del-ங்கிறது determinant of the system, del-ங்கிறது determinant of the system, or here del is to be named as an signal flow graph determinant or characteristic function, since del is equivalent to 0 is the system characteristic equation. Del is equivalent to 0 is the system characteristic equation. Now we need to know what is del. What is del? So del is nothing but del is equivalent to 1 minus sum of all individual loop gains plus sum of the product of the gains of all possible two loops that do not touch each other. So நீங்க எத்தனை possible loops வேணா எடுத்துக்கலாம், but they should not it should not touch each other. Okay, the next one to be are sum of the products of the gains of all possible 3 loops that do not touch each other. அப்ப first வந்து sum of all individual loop gain, second one வந்து sum of the products of the gains of all possible 2 loops which do not touch each other. Next one, sum of the products of the gains of all possible 3 loops that do not touch each other. So it will be it will be going on with the sums of higher number of non-touching loop gain. Okay, then del I ங்கிறது பாத்தீங்கன்னா it is the part of the block diagram that does not touch the ith forward path. நீங்க அந்த எடுத்திருக்கிற part வந்து உங்களோட forward pathல டச் ஆகாம இருக்கணும். ஓகேவா, so if there are no non-touching path, நான் எனக்கு எதுவுமே இல்ல அப்படின்னா don't consider the value to be 0. It has to be considered that it is to be equivalent to 1. எதுவுமே டச் ஆகாம இல்ல எல்லாமே டச் ஆகுது அப்படின்னா we have to make and rule that there is we have to make an assumption that del I value will be equivalent to 1. So this is your Mason's gain formula. So a Mason's gain formula states that summation I is equivalent to 1 to n pi del I divided by del, where pi stands for ith forward path, del I stands for your value of del in the part of the block diagram which does not touch the ith forward path, where del is equivalent to 1 minus sum of all individual loop gains plus sum of the product of the gains of all possible two loops that do not touch each other and sum of the products of the gains of all possible three loops that do not touch each other until so forth with the sums of higher number of non-teaching loop gains. Okay, now let me consider this is to be a signal flow graph. சரியா? அப்ப முதல்ல நம்ம என்ன கண்டுபிடிக்கணும்? We have to find out the forward path. எத்தனை forward path இருக்குன்னு பாத்துக்கோங்க. ஒரு forward path எங்க வருது உங்களுக்கு? G1, G4. அடுத்த வேல்யூ வந்து G2. G1, G4, G2. So வந்து ஒரு forward path. Next forward path பாத்தீங்கன்னா G1, G4. இங்க இருந்து இங்க தாவிருக்கு. So it shift over here. See over here. This is the value of an G3. Upper we'll be getting off and the next forward path to be G1, G3 and your G4. G1, G3 and your G4. Okay. So how many forward path? We'll have two forward path. So we'll have the corresponding to be our corresponding gain to be our G1, G2, G4 and the next one to be our G1, G3, G4. Okay. Now nama we'll be writing the Mason's gain formula. What is the Mason's gain formula? See over here. This is a gain formula. What is the maximum value of n? N is the number of forward paths. Inga ethana forward path irundhathu ungalku? How many forward paths are there? How many forward paths are there? Good. So we'll have a two forward path. அப்ப உங்களோட formula அப்ப உங்களுக்கு we have to replace by I is equivalent to summation இருக்கு. அப்ப P1 del 1 plus P2 del 2 divided by del. P1 del 1 plus P2 del 2 divided by del. Okay வா? Okay. இப்ப P1, P2 நம்ம கண்டுபிடிச்சாச்சு. We have found out the forward path gain ஓட value. Okay. So this is the formula P1 del 1 plus P2 del 2 divided by del P1 P2 கண்டுபிடிச்சாச்சு. இந்த del 1 del 2 கண்டுபிடிக்கிறதுக்கு முதல்ல நம்ம del கண்டுபிடிக்கணும். delங்கிறது என்னது உங்களுக்கு 1 minus sum of individual loop plus minus and plus will be getting changed. Okay, sum of the two individual non-touching loop and it will be going on until the value over here. Say okay. இப்போ இதுல பாருங்க எத்தனை லூப் இருக்குன்னு பாருங்க. லூப்ங்கிறது ரொம்ப ஈஸியா நீங்க ஐடென்டிஃபை பண்ணலாம். என்னன்னு கேட்டீங்கன்னா we will be getting from the feedback value. Feedback H1. இப்போ see over here, this is one loop. இந்த லூப்போட கெயின் என்னன்னு பாத்தீங்கன்னா G1, G4. So it is of to be a H1. So அப்ப it will be equivalent to G1 ठीक है G1, G4, H1. G1, G4, H1. So இது ஒரு லூப். நெக்ஸ்ட் லூப் பாத்தீங்கன்னா so இது ஒரு loop. இந்த loop எங்க போகுது உங்களுக்கு? Which starts over here. G1, G4, answer me. What can be their next loop? G1, G4, G2. So the feedback path here which is to be our minus H2. Upper minus G1, G2, G4, H2. Okay, va? The next loop pathina, see over here. So, sorry, I missed the value over here. I think so. Okay, we'll have only two loops over here. L3 loop on the missed in my problem. I think so. G1, okay, G1, G3, G4. அதாவது நம்மளோட லூப் பாத்தீங்கன்னா இங்க G2 ல இருந்து ஒரு H2 எடுத்துட்டோம். அதே மாதிரி இப்ப G1, G3, G4 minus H2. So இது வந்து உங்களோட மூணாவது லூப். So இது வந்து என்னன்னு கேட்டீங்கன்னா இண்டிவிஜுவல் லூப். These are all to be named as an individual loop. So next என்ன கண்டுபிடிக்கணும் நீங்க? ஏன்னா உங்களோட ஃபார்முலாவே 1 minus sum of individual loop gain. அடுத்து வந்து product of 2 non-touching loop. Next one, product of 3 non-touching loop. Okay ba? So அப்ப இந்த ரெண்டு லூப்பை எடுத்துக்கலாம். G1, G4, H1 ஐயும் G1, G2, G4, H2. நீ ஈஸியா ஞாபகம் வச்சுக்கோங்களேன். It start with G1. Okay வா? திரும்ப it's again start with G1. Definitely you won't get a non-touching loop over here. ஏன்னா என்ன ஆச்சு உங்களுக்கு? எல்லாமே வந்து G1 தான் ஸ்டார்ட் ஆயிருக்கு. ஓகேவா? எதுவுமே தனியா வேற எங்கேயும் ஸ்டார்ட் ஆகல. So அப்ப definitely there are no non-touching loops over here. அப்ப ஃபார்முலா வந்து பாத்தீங்கன்னா வெறும் del is equivalent to 1 minus sum of all individual loop gains மட்டும்தான். அப்ப 1 minus L1 plus L2 plus L3. Okay. So அப்ப 1 minus of L1 plus L2 plus L3 ஓட ஃபார்முலாவை எழுதிக்கோங்க இங்க. Okay, so 1 minus G1, G4, H1 minus G1, G2, G4, H2 minus G1, G3, G4, H2. Okay, va? Next when வந்து okay, so the next one we are in need to find the value of an del 1, del 2, del 1 and del 2. Okay, va? So del 1ங்கிறது என்ன அப்படின்னா so 1 minus sum of அதாவது உங்களோட லூப்பை எடுத்து கொண்டு வந்து இதுல வச்சு பாத்தீங்க அப்படின்னா whether it is to be touching or not. Okay, அதுதான் 1 minus sum of all individual loop gains. Okay, so which is to be your sum of all individual loop gains. Del 1 value will be equivalent to 1 and similarly del 2 value is equivalent to 1 over here. So what about your formula now? C by R is equivalent to P1 del 1 plus P2 del 2 divided by del. So we'll be getting the final expression to be like this. Okay, so this is the way to reduce your signal flow graph. Okay. 1 minute, I'll be back. Okay, next what we are going to see it of Abdina, we are going to see about and how to convert the block diagram into signal flow graph. How to make a conversion of block diagram to signal flow graph. See over here. So இப்போ நீங்க இதுல block diagram வந்து signal flow graph பண்றீங்கன்னு வெச்சுக்கோங்களேன். So what are all the blocks present over here? Okay வா? Right, not a block. So இங்க notations இருக்கு இல்லையா? So R of S, E of S, X1, X2, X3, C of S. So இதுதான் number of nodes. அப்ப when you are counting up here, how many nodes are there? 1, 2, 3, 4, 5, 6 nodes are there. So you can put a 6 over here. Okay va? அப்ப R of S ல இருந்து E of S வந்து will be giving over here. So actually we doesn't. Is my voice is audible? My voice is audible? Is my voice is audible? Okay. Okay. So what will be? So what we'll be doing over here? So we'll be we'll be plotting off and 6 nodes over here. 1, 2, 3, 4, 5, 6, 7 nodes over here. Okay, so when you are making a conversion from RFS into UFS, so we doesn't have any blocks over there. So let me mark which is to be given as here 1, and then from EFS to XWIN, we'll be having the transfer. That is a block which is to be named as here G1. So the gain function to be given as here G1. Then again from X1 to X2, we will be giving as here G2. But at the same time, we will be giving a feedback form also. So which is to be given to be our H2. Okay. Then again from H2, sorry, G2 to G3, G2 to G3. So we'll be having of an X2 over here. Then the next function to be G2, the next function to be a G3, and from we'll be having of an H4. இதுல இன்னொன்னு பாத்தீங்கன்னா C of S ல இருந்து feedback loop வருது. இந்த feedback loop ஓட symbol பாத்துக்கோங்க. If it is to be a positive, then this output to be given as your positive, else it has to be given as your negative. அப்ப இங்க வந்து negative symbol இருக்கிறதுனால I have marked here this is the value to be as minus H1. அதே மாதிரி C from your X3, so X3 to your X1, X3 to X1, I have given the value to be as minus H2. Similarly, from G4 to E of S, G4 to E of S, I have given the value to be minus H3. அப்ப இதுதான் உங்களோட signal flow graph, right? So அப்ப signal flow graphல நீங்க என்ன பண்ணுவீங்க நீங்க? So first step we'll be finding out an forward path. Forward path பாத்தீங்கன்னா ஒரே ஒரு forward path தான் இருக்கு. So we'll be getting off an G1, G2, G3, G4. So formula வந்து பாத்தீங்கன்னா P1 del 1 divided by del. ஓகேவா? So del ஓட formula என்ன? Individual loop gain. Individual loop எடுத்தீங்கன்னா என்னென்ன individual loop வரும் உங்களுக்கு? What about your individual loop? Minus G3, G4, H2. ஓகேவா? அடுத்த loop எடுத்தீங்கன்னா G2, G3, G2, G3, and then followed by with your H2 ஒன்னு இருக்கு. ஓகேவா? அதே மாதிரி உங்களோட G3, G4 following with H1 இருக்கு. அப்ப மூணு இண்டிவிஜுவல் லூப் கெயின் இருக்கும். ஓகேவா? So this is the way to proceed up your signal flow graph. Okay. Next, actually, we are in need to do about your steady state analysis. That is your transient and steady state response. Okay. When we are saying up here in time domain analysis, so the response of a dynamic system will be expressed as a function of time. Will be expressed as a function of time. Okay. So it is possible to compute the time response of the system if the nature of the input and the mathematical model of the system are known. Okay. So usually the input signals to control system are not known fully ahead of time. Okay. What are all the standard test signals? Okay, so first of all, we are in need to know what about the characteristics of input signal. What about the characteristics of input signal? So characteristics of input signal will have a sudden shock, sudden change, a constant velocity, and a constant acceleration. We'll have a shock, change, constant velocity, and a constant acceleration. Okay. When you are defining a dynamic behavior of a system, we'll have a standard test signal which is to be named as an impulse signal and step signal. Impulse signal and step signal will have a constant velocity and constant acceleration. They will be having of a constant velocity and constant acceleration. So you can be expected. What are the signals which have a constant velocity and constant acceleration? Or what are the characteristics of an input signal? Sudden shock, sudden change. Okay, so these are all the characteristics of an input signal. Okay, so the other standard signal of great importance is to be a sinusoidal signal. So let me see one by one. So what is an impulse signal? Impulse signal, we know that the usual notation is denoted by means of an del of t. Okay, and it initiates the sudden shock characteristics of an actual input signal. So the value of del of t is equivalent to a when t is equivalent to 0. when t is equivalent to 0, the value of del of t is equivalent to a. So this is the characteristics of an impulse signal over here. So del of t is equivalent to a. Okay. The next one, step signal. So when you are saying about an step signal, actually when t is greater than before that unit impulse, இது வந்து normal impulse signal which is to be given as here a. அதே unit impulse na the value which is given here to be 1. Which is given here to be 1. So that is to be our impulse. Similarly, the step signal. Step signal பார்த்தீங்க அப்படின்னா it initiate the sudden change characteristics of an input signal. அதாவது when t is greater than or equal to 0. When t is greater than or equal to 0, then the step signal value will be equivalent to a. அதே வந்து if a is equivalent to 1, அப்படின்னா then the step signal is to be named as an unit step signal. இங்க a க்கு பதிலா உங்களுக்கு வந்து 1 இருந்ததுன்னா it is to be named as an unit step signal. Under condition என்னன்னா when t is greater than or equal to 0, அதாவது 0 1 up to n வரைக்கும் பாத்தீங்கன்னா the value will be a constant one. Next one to be the unit ramp signal. Unit ramp signal na enna solveenga neenga? When t is equal to 0, the amplitude will be 0. When t is equal to 1, amplitude will be 1. When t is equal to 2, amplitude will be 2. So we'll have a linear variations corresponds with the t and r of t. Corresponds with the value of t and r of t. அப்ப r of t எப்படி note பண்றோம் அப்படின்னா which is to be our ap. Okay. So அப்ப constant velocity characteristics நீங்க பாத்துக்கோங்க. Step signal வந்து sudden change characteristics, whereas impulse signal வந்து sudden shock characteristic, then vary a ramp signal which have a constant velocity characteristics. Okay, the next one to be the parabolic signal. So what about the parabolic signal? So parabolic signal வந்து it imitate the constant acceleration characteristic of actual input signal. Okay, and we know that y of t is equals to 8t square divided by 2 when t is greater than or equal to 0. To be greater than or equal to 0. Okay. So if a is equivalent to 1, then it is to be named as a unit parabolic signal. See over here. So it will be having of a constant variation. So one more thing you have to remember it that when you are making a conversion from impulse to step or from step to ramp or ramp to parabolic, then you have to make an integration. You have to make an integration. அதுவே நீங்க ரிவர்ஸ்ல பண்றீங்கன்னு வெச்சுக்கோங்களேன். So thing has to be that parabolic to ramp or ramp to step or step to impulse அப்படின்னா you have to do a differentiation. ஓகேவா? இல்ல இப்ப எனக்கு impulseல இருந்து டைரக்டா ramp வேணும் அப்படின்னா you have to make an integration of 2 times. So these are all the standard test signals. So L of t will be equivalent to a when t is equal to 0. L of u of t is equivalent to a when t is greater than or equal to 0. For ramp signal, r of t is equivalent to t when t is greater than or equal to 0. And then finally, parabolic signal is equivalent to 8t square divided by 2 when t is greater than or equal to 0. So இதுக்கு Laplace transform கண்டுபிடிக்க தெரியணும். We know that what is the Laplace transform? 1 is nothing but 1 by s. அப்ப a க்கு எடுத்தீங்கன்னா என்ன வரும்? a by s. அதே மாதிரி u of t ங்கிறது 1. So u of t ங்கிறது 1 ங்கும்போது what will be getting over there? When you are finding for your Laplace transform of step signal, so we know that 1, so 1 by s over here. Okay, va? The next one, what will be getting off over and abdina? Ramp signal. So ramp signal, we will be getting off here r of s. So we will be t. So Laplace transform of t to be r. Laplace transform of t to be r. Actually, t power n வந்து n factorial divided by t power n plus 1. T power n plus 1. So similarly here over here, so since we are having a t, so which is nothing but an 1 by s square, because t is power 1, so n factorial 1 factorial divided by s power n plus 1, so we'll be getting off an s squared over there. Okay, the next one to be our parabolic. So parabolic பார்த்தீங்க அப்படின்னா 8t square divided by 2. So அதே மாதிரி தான் இது a by 2ங்கிறது கான்ஸ்டன்ட் வேல்யூ, a by 2ங்கிறது கான்ஸ்டன்ட் வேல்யூ. சோ அப்ப நீங்க என்ன பண்றீங்க, லாப்லேஸ் ட்ரான்ஸ்ஃபார்ம் ஆஃப் t ஸ்கொயர் கண்டுபிடிப்பீங்க. t ஸ்கொயர்னா என்ன வரும் உங்களுக்கு? So 2 divided by t cube. So 2 and 2 will be getting cancelled. அப்ப at squared by 2 லாப்லேஸ் எடுத்தீங்கன்னா we'll be getting the solution to be a divided by s cube. a divided by s cube. Okay va? The next what we are need to find out அப்படின்னா we have to find out the time response of a dynamic system. Time response of the dynamic system. So time response பாத்தீங்கன்னா actually it will be classifying into two components. One to be the transient response and other one to be the steady state response. One to be the transient response and other one to be the steady state response. So let me see what is called transient response, what is called steady state response. Okay, va? So when the response of the system is changed from equilibrium, it takes some time to settle down. Okay, see over here. So when it is changed from equilibrium, it takes some time to settle down. So அதுக்கு பேரு தான் என்ன சொல்றோம் அப்படின்னா transient response அப்படின்னு சொல்றோம் நம்ம உங்களுக்கு. Okay. Similarly, the response of the system after the transient response. Okay. So then that is to be named as your steady state response. See, when it is changed from equilibrium, it takes some time to settle down. So இது பேரு தான் என்ன சொல்றோம் அப்படின்னா transient. So after transient response, what is the response of the system? Then that is to be named as your steady state response. Okay. Then what about the time response of the control system? Okay. So transient response பாத்தீங்கன்னா depend upon the system poles only, not on the type of input. அதாவது நம்ம input என்ன கொடுக்குறோம், polesனா தெரியல. What about your poles and zeros? Which are located in the denominator, which is to be named as an poles over here. Zeros-ங்கிறது வந்து பாத்தீங்க அப்படின்னா it will be at the numerator. Okay va? So a transient response which depends upon the system poles only, not on the type of input. Okay. So usual transient response வந்து it is sufficient analysis using a step input. Okay. The steady state response வந்து depends on system dynamics and the input quantity. And last one, we can able to examine the different signals by using the final value presentation. Okay. இப்போ இங்க பாருங்க. இப்போ the first order system K has only one pole. அதாவது one poleங்கிறது இங்க denominator. ஓகேவா? So C of S divided by R of S எடுத்திருக்கேன் நானு. So K divided by Ts plus 1. இந்த K இருக்கு பாத்தீங்களா, மேல நியூமரேட்டர்ல we'll have the value of an K. இந்த Kங்கிறது தான் என்ன அப்படின்னு பாத்தீங்கன்னா DC gain. ஓகேவா? இந்த Tங்கிறது டைம் கான்ஸ்டன்ட் ஆஃப் சிஸ்டம். அதாவது Sங்கிற ஃபேக்டருக்கு முன்னாடி என்ன வேல்யூ இருக்கோ அதுதான் வந்து என்னது உங்களுக்கு which is to be represented as an time constant of the system. ஓகேவா? So அப்ப what is time constant? Time constant is the measure of how quickly a first order system responds to a unit step input. Okay, so time constant அப்படிங்கிறது என்னன்னா it is a measure of how quickly a first order system responds to a unit step input. Okay, சரி, okay. For example, இப்போ இதான் உங்களோட எக்ஸாம்பிள் பாத்துக்கோங்க. 10 divided by 3s plus 1. 10 divided by 3s plus 1. I said you that the DC gain to be 10. DC gain to be 10 over that, and the value of time constant to be 3. Time constant to be 3. Okay. So for the following system, see over here. அதாவது S ஓட ஃபேக்டர்ல, அதாவது you should have the constant term over இங்க n இருக்கணும் உங்களுக்கு. You should have the expression K divided by 1 plus ST. ஓகேவா? அப்ப இங்க என்ன டேர்ம் இருக்கு உங்களுக்கு? இங்க 5 இருக்கு. So அதனால I divide the expression by 5. So what will be getting over on it? So 1 divided by 5 into S plus 1. So அதே மாதிரி then it will goes into over here, will be getting of an 3 by 5. Upper DC gain and your seconds are to be the representation. Okay, next one, consider the following first order system. இப்போ வந்து நம்ம first orderங்கிறது என்ன உங்களுக்கு ஆர்டர் சொல்லிருக்கீங்க ஞாபகம் இருக்கு இல்லையா? Order is the highest power of s in the denominator. Okay, இங்க s ஓட வேல்யூ என்ன இருக்கு 1. so அப்ப it is of to be our first order system. இங்க input என்ன கொடுத்திருக்கோம்னா del of s கொடுத்திருக்கோம். what is del of s? it is to be the unit impulse signal. It is to be the unit impulse signal. So what we know that unit impulse signal to be is equivalent to 1. Unit impulse signal to be equivalent to 1 when t is equivalent to 0. Okay va? So C of s வந்து பாத்தீங்க அப்படினா we'll be getting of an k divided by ts plus 1. Okay, so we'll be rearranging the equation. So what will be getting over here? K divided by t divided by so s plus 1 by t. So அப்ப இதுக்கு வந்து நீங்க லாப்லாஸ் இன்வெர்ஸ் எடுத்தீங்கன்னா what will be getting over on it? s plus a. s plus a ங்கிறது என்ன சொல்லி கொடுத்தா உங்களுக்கு e power minus at. c ங்கிறது constant term. அப்ப instead of having a c, what will be having over here? K by t into e power minus t by capital T. This is the way to find out your response of your first order system. Similarly, the next to be your step response of a first order system. So, for example, C of s is equivalent to k of 1 by s minus 1 t by ts plus 1. So, இதோட inverse Laplace எடுக்கிறீங்க 1 by s ஓட inverse 1 க்கு எடுத்தாவே என்ன ஆகும் உங்களுக்கு 1 by s வரும். 1 by s ஓட inverse Laplace transform it will be u of t minus e power t by capital T. So we'll be getting often c of t is equivalent to k of 1 minus e power minus t by t. So this is the final expression that you have to remember for your step response of your first order system. Step response of your first order system. And what is the relationship between your step response and your impulse response? So நம்ம சொன்ன ஞாபகம் இருக்கா உங்களுக்கு? Can you able to remember this slide? We have to make an impulse to step அப்படின்னா derivation. அதுவே step to impulse na differentiation. Okay va? So that is what we'll be seeing over now. The step response of the first order system நமக்கு என்ன தெரியும் k of 1 minus e power minus t by t. So we are differentiating as c of t with respect to t. Okay. So k by t e power minus t by t. Okay. For example 1 e power minus 0.5 t. Find out the time constant, gain, transfer function and step response. Okay, so அப்ப உங்களோட கொடுத்திருக்கிற equation என்ன இருக்கு உங்களுக்கு c of t is equivalent to 3 into e power minus 0.5 t இருக்கு. So e power minus 0.5 t க்கு inverse Laplace எடுத்தீங்கன்னா என்ன வரும் 1 divided by s plus 0.5. கரெக்ட்டா? s plus 0.5. இந்த 1ங்கிறது என்னது will be replacing by means of an impulse response value. ஓகேவா? So this is to be r, so which denoted as an del of s. So c of s divided by l of s is equivalent to, so when you are getting the expression 3 divided by s plus 0.5. Okay va? So in the 0.5 simplify பண்றதுக்கு what will be doing over here now 1 by 0.5. 1 by 0.5 ங்கிறது என்ன வரும் உங்களுக்கு 2s plus 1. Okay va? அப்ப again 1 by 0.5 ங்கிறது 2. அப்ப 6 by 2s plus 1. அப்ப இதுதான் உங்களோட expression. இப்ப சொல்லுங்க what is the value of DC gain and what is time constant? What is the value of DC gain and what is the value of time constant? Please make it fast. Example வேணா காமிக்கலாமா 10 divided by 3s plus 1. 10 divided by 3s plus 1. So இப்படி இருக்கும்போது உங்களோட DC gain வந்து 10. A time constant to be 3 seconds. A time constant to be 3 seconds. So similar way, you compare with this expression and say me the answer for this value. This is your expression. Please say your DC gain and your time constant. Make it fast. Anyone? Say DC gain மட்டும் சொல்லுங்க. Time constant கூட வேணாம். DC gain மட்டும் சொல்லுங்க. அப்பாடா. Good. Thank you. Time constant சொல்ல மாட்டீங்க. Okay. Good. Thank you so much. So your time constant to be 2 and DC gain to be 6. Thank you so much. Okay, the next one நீங்க என்ன பண்றீங்க அப்படின்னா, so transfer function நீங்க கண்டுபிடிச்சிருக்கீங்க இல்லையா? What is transfer function? It is the ratio of Laplace transform to the output divided by Laplace transform of input. அதுதான் நீங்க என்ன கண்டுபிடிச்சிருக்கீங்க? C of s divided by R of s is equivalent to 6 divided by 2s plus 1. Okay va? So the last thing what you have to find out அப்படின்னா, we have to find out the step response. நம்ம ஸ்டெப் ரெஸ்பான்ஸ் என்ன பண்ணணும் உங்களுக்கு, பிகாஸ் கொடுத்திருக்கிற ஈக்குவேஷன் என்ன உங்களுக்கு, what it is given impulse response கொடுத்திருக்காங்க கரெக்ட்டா, the impulse response of first order, but we are in need to find the value of an step response. அப்போ what you have to do it of, so impulse ல இருந்து step அப்படிங்கும்போது we have to do the integration. So do the integration of c of t into dt. So 3 to be the constant, integration of e power minus 0.5t. அப்ப minus will be coming over on it. So divided by 0.5 varum. So we'll be getting off and minus 6 e power minus 0.5t into plus c. So we can find out c if initial condition is known. Upper initial condition we can make an assumption 0. So we'll be getting the value of to be 6. Upper step response pathinga appadina c of t is equivalent to 6 minus 6 e power minus 0.5t. 6 minus 6 e power minus 0.5t. Okay va? ஓகே, இப்போ சப்போஸ் உங்களோட இனிஷியல் கண்டிஷன்ஸ் ஆர் நாட் நோன் அப்படின்னா நீங்க என்ன பண்ணணும்னா, யூ ஹாவ் டு ஆர்எஃப்எஸ்ங்கிறது ஸ்டெப் இன்புட், ஆர்எஃப்எஸ்ங்கிறது ஸ்டெப் இன்புட், அதாவது ஆர் ஆஃப் டிங்கிறது 1, அப்ப ஆர்எஃப்எஸ்ங்கிறது 1/s, அப்ப சி ஆஃப் எஸ் மட்டும் நீங்க எடுத்துக்கோங்க. If you have taken up over there, what will be getting 6 divided by s into 2s plus 1. அப்ப இனிஷியல் கண்டிஷன்ஸ் தெரியலன்னா you have to simplify the expression using the partial fraction. Using the partial fraction. அப்ப partial fraction என்ன பண்ணுவீங்க நீங்க, ரெண்டு factors இருக்கு, a divided by s plus b divided by 2s plus 1. Okay va? So solve this equation, find out the value of an a and b. Okay, and then you'll be getting the final answer to this. Okay va? See over here. So by solving of your a and b partial fraction, I think so you have known. I don't want to go deep. Okay, so by solving that you can able to find the value of an a and b. So what is the inverse Laplace? We have taken inverse Laplace. Okay, so 1/s Laplace to be inverse to be 1. Appa 6/s to be 6. Adhe madri 1/s plus a to be e power minus 8t. So you'll be getting of an e power minus 0.5t. Okay, so appa this is the way to find over here. So இது வரைக்கும் நம்ம பார்த்தது எல்லாமே first order system. What we have seen over now, first order system. Okay va? The next we have to see about your second order system. So let me have a 2 minutes break. I'll come back. Thank you. So far, what we have seen over now, Abdina, we have seen about your first order system. So now we are going to see about your second order system. Okay. So when we are saying about an second order system, it is characterized by means of an transfer function. So since over here, the feedback which is not given here, so we will be considering it is to be a unity feedback system. So the after simplification of our expression, this is your second order equation. So we have to know blindly what is the surface for second order system, which is to be given over here to be omega n s plus omega n squared. Okay, so where here omega n stands for your undamped natural frequency of the second order system, and tau is to be named as your damping ratio of the second order system. So undamped natural frequency and tau is to be a damping ratio. Okay, so for example, this is your characteristic equation. So when you are saying up here 4 divided by s squared plus 2s plus 4. So comparing these two equations, comparing these two here, second order equation. So what will be getting over that? Omega n squared is equivalent to 4. Omega n squared is equivalent to 4. About what is the value of omega n? Obviously it is equivalent to 2. Similarly, you compare the denominator value. Here we are having the parameter 2 tau omega n. 2 tau omega n is equivalent to 2. Okay, and we found out that omega n is equivalent to 2. What will be getting over here? So 2 tau omega n is equivalent to 2s, and omega n is equivalent to, so tau omega n is equivalent to 1. So omega n we have found out is equivalent to 2. The value of tau is equivalent to 0.5. So this is the way to know about to find out the value of an undamped natural frequency and about your damping ratio. Damping ratio. Okay. I think so. The example is clear to find out the value of an undamped natural frequency and about your damping ratio. Okay. Then the next thing we are in need to about the poles. Okay. So when we are simplifying this expression, so it will be in the poles. That is when you are simplifying s squared plus 2 tau omega n s plus omega n squared, the poles of the system which is given over here to be minus omega n tau plus omega n square root of tau squared minus 1 and minus omega n tau squared minus 1. Actually, the tau, what is tau? I said you that damping ratio. So based on the damping ratio, that is depend upon the value of damping ratio, we can classify our system. Okay, so what is our system says that the system, the first is to be named as an overdamped system. So when you are saying up here, if the tau is greater than 1, if you are founding the tau is to be greater than 1, then the system is to be named as an overdamped system. Okay, and if they have two real distinct poles, then it is to be named as an overdamped system. And similarly, the next one, if we are saying that if the system has two complex poles, that is, if it is lesser than 1, if the value of tau is to be lesser than 1, then that is to be named as an underdamped system. Similarly, if it is to be 0, tau is equivalent to 0 abdina, then it is to be named as an undamped system. Okay, so tau is greater than, when tau is equivalent to 1, critically damped. So we'll have a 4 value, tau is greater than 1, overdamped, tau is less than 1, underdamped, tau is equivalent to 0, undamped, tau is equivalent to 1, critically damped system. Okay. Okay. So based on the characteristics, we'll have important timing characteristics which are to be named as an delay time, rise time, peak time, maximum overshoot and settling time. So இது எல்லாமே உங்களோட formulas you try to recollect it. What is the formula for delay time? What is the formula for rise time? What is the formula for peak time, settling time, maximum overshoot? Okay. Because you will be expecting 1 mark question or 2 mark question, calculate this peak time or your rise time or your delay time. Okay. So when you are saying up here, see, this is the characteristics the rise time, peak time, settling time, your maximum peak overshoot. Okay, delay time. Okay, wow. So in the rise time பாத்தீங்கன்னு வெச்சுக்கோங்களேன். So when it is starts from the initial value ல இருந்து உங்களோட first rise up value. So in the time duration தான் it is to be named as your rise time. அதே மாதிரி first when the signal attain its peak value, when the signal attain its first peak value, it is to be named as your peak time. Settling time ங்கிறது பாத்தீங்க அப்படின்னா where it is settled down to this position, original positionக்கு எங்க செட்டில் ஆகுதோ இந்த settling time வரும். Usually இந்த settling time பாத்தீங்க அப்படின்னா it will be in the around the percentage with time will be 0.05 or 0.02. ஓகேவா? So இந்த this is the value, அதாவது இந்த peak timeக்கும் rise timeக்கும் இருக்கிற difference வந்து என்னன்னு பாத்தீங்க அப்படின்னா we'll be getting of an maximum peak overshoot. ஓகேவா? So உங்களோட risingல அதாவது starting pointல இருந்து little bit delay ஆகுறது, அதாவது ரைஸ் டைம் ரீச் ஆகுறதுக்குள்ள இருக்கிற டிலே வந்து என்ன அப்படின்னா will be representing this to be an delay time. So your notations பாத்தீங்கன்னா delay time will be given as an TD, whereas your rise time will be for us TR, peak time which is given for your TP, settling time TS, and maximum peak overshoot to be MP. Okay, okay, this is your delay time. See over here, this is the time required for the response to reach half the final value the very first time. So first in the half of the value, அதாவது reach ஆகிறதுக்கு முன்னாடி இருக்கிற the half of the value தான் என்ன சொல்றோம் உங்களுக்கு delay time னு சொல்றோம் உங்களுக்கு. ஓகேவா? அதே மாதிரி rise time. So rise time வந்து I said you that the rise from 10 to 90 or 5 to 95 or 0 to 100%. So உங்களோட final value cases வரும்போது so under damped என்ன சொன்னேன் உங்களுக்கு when tau is less than 1, கரெக்ட்டா? So when tau is less than 1 இருக்கும்போது normally உங்களோட rise time வந்து பாத்தீங்கன்னா 0 to 100% இருக்கும். For over damped பாத்தீங்க அப்படின்னா 10% to 90% வந்து இருக்கும். சரியா? This is about your rise time. Next, peak time. Peak time, I said you that it is the time required for the response to reach the first peak of the overshoot. உங்களோட first value ஓட attain பண்றது தான் என்னது உங்களுக்கு peak time. Next, maximum peak overshoot. This also already defined you that it is the maximum peak value of the response curve measured from unity. So if the final steady state value of the response differs from unity, then it is common to use the maximum percentage overshoot. So it is defined as by the formula this one, C of TP minus C of infinity divided by C of infinity into 100. Okay, where the amount of maximum peak overshoot வந்து எதை indicate பண்ணுதுன்னு பாத்துக்கோங்க, which indicates the relative stability of the system, The next the thing, settling time, this also I explained you, which is that it is the time required for the response to reach and stay within a range about the final value of size. So usually எவ்வளவு percentage சொல்லிருக்கோம் நான் உங்களுக்கு, it is to be 2% or around 5% over that. Okay, so this is your expression omega n squared. What is the step response of under damped system? Okay, omega n squared divided by s squared plus 2 tau omega ns plus s. So r of s is the unit step response. So 1 by s squared, partial fraction எடுத்துக்கோங்க, a minus b. சரிங்களா? So that I think so this is not necessary anyway. So okay, damped அதாவது என்ன சொன்னா இது வரைக்கும் உங்களுக்கு omega n சொல்லிருக்கேன் இல்லையா, omega nங்கிறது undamped natural frequency சொல்லிருக்கோம், tauங்கிறது damping ratio சொல்லிருக்கோம். One more factor, damped natural frequency omega d எப்படி calculate பண்றோம்னா omega n into root of 1 minus tau square. Omega d is equivalent to omega n into root of 1 minus tau square. சரியா? So அதுதான் வந்து damped natural frequency. இது எல்லாமே உங்களோட ப்ராப்ளம்ல கேக்குற repeated standard notations தான் இது எல்லாமே உங்களுக்கு. Okay, then inverse Laplace transform. So this is a step response. So இது just you recollect your thing alone. So I think so this derivation is okay. Under damped system ஓட response வந்து 1 minus cos omega nt. இத மட்டும் ஞாபகம் வச்சுக்கோங்க. Under damped வந்து 1 minus cos omega nt. ஓகேவா? And then we'll having of around steady state error. We'll having around an steady state error. Steady state error பாத்தீங்க அப்படின்னா if the output of a control system at steady state வந்து if it does not exactly match with the input, if the output of a control system at steady state does not exactly match with the input, abdina, the system is said to have a steady state error. Okay, so any physical control system inherently which is suffers steady state error in response to certain type of inputs. இப்போ நம்ம என்னென்ன ஸ்டாண்டர்ட் டெஸ்ட் சிக்னல்ஸ் பார்த்தோம் ஞாபகம் இருக்கும், அதுதான் உங்களோட இன்புட் சிக்னலா இங்க வரும். என்னென்ன நம்ம ஸ்டாண்டர்ட் டெஸ்ட் சிக்னல்ஸ் பார்த்தோம்? Anyone please? Any standard one test signal? Any one of the standard test signal? What are the standard test signals I said you? Can't you able to remember? Step signal, impulse signal. Okay, இங்க நம்ம என்ன input பார்க்கிறோம் அப்படின்னா, we are going to classify it according to the following ability: step input, ramp input, parabolic input. Step input, ramp input, and your parabolic input. Okay.
Yeah.
So let me consider the unity feedback system. Unity feedback system. Let me considering over that. நான் already உங்களுக்கு என்ன சொல்லியிருக்கேன், நியூமரேட்டர்ல இருக்கிறது எல்லாம் வந்து நேம் டு பி as an zeros, டினாமினேட்டர்ல இருக்கிறது எல்லாமே வந்து போல்ஸ். ஓகேவா? சோ இங்க வந்து நம்ம வந்து உங்களோட ஸ்டடிஸ் அனுப்பும்போது s power n in the denominator which representing the n poles at the origin. ஓகேவா? representing the n poles at the origin. So a system is called type 0, 1, 2 depends upon the n value. இப்ப நம்ம லாஸ்ட் டைம் பார்க்கும்போது ப்ராப்பர் சிஸ்டம் பார்த்தோம் ஞாபகம் இருக்கா? உள்ள மல்டிப்ளை பண்ணிட்டு அந்த ஹையஸ்ட் பவர் ஆஃப் எஸ்ங்கிறத நம்ம என்னன்னு சொல்லி ஆர்டர் சொன்னோம். கரெக்டா? Can you able to remember that? When you are finding an order of a system, so for example, if you have s into s plus 4 into s plus 2, we said that the order to be 3 because we'll multiplying that we'll be getting of an s cube plus some 12s square plus some 12s we'll be getting. Okay. ஆனா இங்க வந்து பாத்தீங்க அப்படின்னா we have to represent the poles of the s value. இங்க என்ன represent பண்ணுதோ அதுதான் வந்து உங்களோட type 0 type system. It will be defined as a type 0, type 1, type 2 if n is equivalent to 0, 1, 2, 3 respectively. Okay. So as the type number is increased, what will happen abdina? So the accuracy is improved. Okay. So this increasing the type number aggravates the stability problem. So a compromise between steady state accuracy and relative stability is always necessary over it. Okay. So this is about your steady state error of unity feedback system. Unity நாலே உங்களுக்கு என்ன சொல்லிருக்கேன் உங்களுக்கு நானு, அதாவது h of s ஓட வேல்யூ 1. அப்ப இந்த க்ளோஸ் லூப் ஓட ட்ரான்ஸ்ஃபர் ஃபங்க்ஷன் சொல்லுங்க பார்க்கலாம். So which is nothing but an g of s divided by 1 plus g of s. ஓகேவா? h of s வரும். h of s ங்கிறது யூனிட்டிங்கிறதுனால we'll be getting of around g of s divided by 1 plus g of s. Okay. So இதோட ஜெனரல் நோட்டேஷன் இங்க எழுதுறோம் நம்ம. Okay. So this s power n determines your type system. Okay. Steady state error of a unity feedback system. So உங்களோட இங்க steady state error is defined as the error between the input signal and the output signal when t tends to infinity. Steady state error is defined as the error between the input signal and the output signal when t tends to infinity. இப்போ for example உங்களோட error signal என்னது உங்களுக்கு இங்க உங்களோட பிளாக் டயகிராம்ல நீங்க பார்த்திருப்பீங்க. Actually input வந்து r of s, output வந்து c of s, error signal வந்து e of s. ஓகேவா? சோ அப்ப e of s divided by r of s பாத்தீங்கன்னா which is equivalent to 1 divided by 1 plus g of s. ஓகேவா? சோ உங்களோட ஃபைனல் வேல்யூ தியரம் வந்து என்ன பண்ணும்னா which will provide a way in order to find the steady state performance of a stable system. In order to provide the steady state performance of a stable system. So what is E of S? சோ அப்ப E of S போது என்ன பண்ணுவீங்க நீங்க உங்களோட இன்புட் வந்து R of S அந்த பக்கம் எடுத்துட்டு போயிடுவீங்க. So we'll be getting often 1 divided by 1 plus G of S. So what we have defined steady state error அதாவது உங்களோட value T has to make an infinity. அப்போ what we'll be doing over on it? We have to take the inverse form. சரியா? Okay. So E of S வந்து 1 divided by 1 plus G of S into R of S. So take a inverse Laplace transform and use the notation ESS. ESS தான் என்னது உங்களுக்கு steady state error. Steady state error. அப்ப limit இது வந்து உங்களுக்கு ஒரு theorem இது actually. Initial value theorem, final value theorem இருக்கும். I think so you can able to remember and you are studied in signals and systems and probably M3 or M4. I could not able to remember it. Okay. So the thing has to be that this is the final value theorem. Final value theorem na enna ungoda left hand side la when limit t tends to infinity E of t. So in the right hand side la it has to be equivalent to limit s tends to 0 s into E of s. Limit t tends to infinity E of t which is equivalent to limit s tends to 0 s into E of s. Okay va? அப்ப இதுதான் உங்களோட E of s ஓட வேல்யூ கரெக்ட்டா? அப்ப s into R of s divided by 1 plus G of s. எப்போ when the limit value s tends to 0. அப்ப இதுதான் உங்களோட steady state error of an unity feedback system. So அப்ப you can blindly say that ESS equivalents to limit t tends to அதாவது உங்களோட ப்ராப்ளம் வந்து E of t ல கொடுத்திருந்தாங்கன்னு வெச்சுக்கோங்க. You just make it as an t tends to infinity. Otherwise you make it as an s tends to 0. If the given problem in s, so what you should do it of? You have to make s to be 0. S into R of S divided by 1 plus G of S. Okay va? Okay. So next one வந்து பாத்தீங்க அப்படின்னா static error constants. We'll be having often static error constants. So static error constants வந்து பாத்தீங்கன்னா actually it is to be the figure of merit of the control systems. The higher the constants, the smaller the steady state error. The higher the constants, the smaller the steady state error. So already அங்க என்ன இன்புட் சொன்னேன் உங்களுக்கு நானு will have a unit step ramp and the parabolic input. ஓகேவா? சோ ஒரு given systemல வந்து output may be the position, velocity, pressure, temperature or the like. Okay. So இப்போ நீங்க வந்து for example position call பண்றீங்கன்னு வெச்சுக்கோங்க. What does it meaning that it is the rate of change of the output velocity. So இந்த மாதிரி போயிட்டே இருக்கும். அதே மாதிரி இப்ப temperature control systemல position பண்றோம். Position represents the output temperature அப்படினா velocity will represent the rate of change of the output temperature. Okay va? So this about your static error constants. So next to be your static position error constant. So static position error அதாவது என்னன்னு கேட்டீங்கன்னா actually static error constant வந்து மூணு constant இருக்கு. Position error constant, velocity error constant, acceleration error constant. Okay. Position error constant, velocity error constant, acceleration error constant. That is Kp, Kb, Ka. Kp, Kb, Ka. Okay. So உங்களோட Kp ஓட வேல்யூ என்னன்னு கண்டுபிடிக்கலாம். First one. So steady state error ஓட ஃபார்முலா என்ன தெரியும் உங்களுக்கு? ESS equivalents to limit s tends to 0 s divided by 1. அதாவது R of s இருக்கு இல்லையா? R of s ங்கிறது என்னது உங்களுக்கு? Since we are making an unit step input, we know that the Laplace value of an R of s is equivalent to 1 by s. அதனால தான் அங்க 1 by s ன்னு replace பண்ணிருக்கேன். ஓகேவா? So s into R of s divided by 1 plus G of s. So s s cancel ஆயிடுது. I am replacing G is equivalent to 0. அப்ப உங்களோட Kp எப்படி கண்டுபிடிப்பீங்க அப்படின்னா Kp is equivalent to limit s tends to 0 G of s, which is nothing but the value to be is equivalent to G of 0. This is the way to find out your position error constant. Okay va? அப்ப steady state error வந்து position error constant கண்டுபிடிச்சீங்கன்னா ESS equivalent to 1 divided by 1 plus Kp. ESS equivalent to 1 divided by 1 plus Kp. Next வந்து பாத்தீங்க அப்படின்னா சரி ஓகே. இப்ப type 0, type 1 பார்க்கலாம். So type 0ங்கிறது என்ன உங்களுக்கு? இங்க s பவரை நான் எந்த வேல்யூமே வச்சிருக்கல. அதாவது which means that s power 0 which indicates the value to be 1. ஓகேவா? So இங்க s power 0 னு வச்சா 1. Actually இங்க வந்து இங்க so the thing is to be that So this is your type 0. அப்ப KP நான் இங்க கண்டுபிடிக்கிறேன் நான் உங்களுக்கு. So இங்க கண்டுபிடிக்கும் போது type 0ல பாத்தீங்கன்னா I have to replace S is equivalent to 0. S is equal to 0 னா என்ன ஆகும் உங்களுக்கு? Entire term will be equivalent to K. Entire term will be equivalent to K. அதே மாதிரி type 1. Type 1ல வந்து KP என்ன ஆயிடுது எனக்கு? Infinity ஆயிடுது. ஓகேவா? So for a unit step input வந்து K அதாவது steady state error ஓட value வந்து type 0வா இருக்கும்போது மட்டும்தான் we will be getting the constant value 1 by 1 plus K. அதுக்கு மேல போயிட்டாலே the value will become infinity. ஏன் நான் இங்க 0ன்னு போட்டிருக்கேன்னு பாருங்க. அதாவது sorry I've said infinity. It should be 0 because ESSங்கிறது என்ன நமக்கு தெரியும்? 1 divided by 1 plus KP. 1 plus KP. KPங்கிறது என்னது உங்களுக்கு? Infinity. அப்போ 1 plus infinity 1 by 1 plus KP தானே? Okay. So we'll be getting often type 1 or higher system to be equivalent to 0. Next one வந்து பாத்தீங்கன்னா velocity error constant. Velocity error constant என்ன பண்றோம் நம்ம உங்களுக்கு எந்த இன்புட்டுக்கு கன்சிடர் பண்ணுவோம்? Position error வந்து unit step response. Positions வந்து unit step response. Next one பாத்தீங்க அப்படின்னா velocity error constant. Velocity error constant எதுக்கு பண்றோம் நம்ம? It goes for unit ramp input. Velocity error goes for an unit ramp input. Unit ramp input வந்து என்னன்னு பாத்தீங்கன்னா 1 by S square. ஏன்னா ramp உங்களுக்கு ஞாபகம் இருக்கு இல்லையா? Because R of t is equivalent to A into T. A constant unit வெச்சுக்கோங்களேன். R of t is equivalent to T. What is the Laplace transform of T? We know that T for n is equivalent to n factorial divided by T for n plus 1. அப்ப T ஓட value என்ன உங்களுக்கு? 1 divided by S squared. அப்ப you replace over here. What will happen? S and S will be getting cancelled. You will be getting the expression 1 by S into G of S. So அப்ப KBங்கிறது என்னன்னா limit S tends to 0 S into G of S. ESSங்கிறது என்னது உங்களுக்கு? 1 divided by KB. ஓகேவா? இப்ப டைப் 0 கால்குலேட் பண்ணுவோம். டைப் 0 கால்குலேட் பண்ணா என்ன அர்த்தம் உங்களுக்கு? அதாவது when S tends to 0. S tends to 0வா இருக்கும்போது so எல்லா வேல்யூமே 0 ன்னு ஈக்குவேட் பண்ணுவீங்க. அப்ப என்ன ஆயிடும் உங்களுக்கு? This value will be becomes 0. டைப் 1 பண்ணுங்க. டைப் 1 னா என்ன பண்ணுவோம் நம்ம? S power n. S and S will be getting cancelled. You'll be getting a constant term K. அப்ப டைப் 2க்கு போகும்போது S squared. ஒரு S ஒரு S கேன்சல் ஆயிடும். அப்ப இது இன்ஃபினிட்டி ஆயிடும். அப்ப what you can able to conclude it அப்படின்னா அதாவது 1 by KB for infinity. இப்ப for type 0. டைப் 1க்கு கான்ஸ்டன்ட்டா இருக்கும். ஓகேவா? அதே மாதிரி more than that it will be equivalent to 0. சரியா? அப்ப இந்த நோட்டேஷன் உங்களுக்கு ஈஸியா ஞாபகம் இருக்கணும். அதாவது இப்ப நம்ம KP என்ன சொன்னோம் உங்களுக்கு? டைப் 0க்கு வந்து 1 by 1 plus KP ன்னு சொன்னோம். டைப் 1க்கு வந்து டைப் 1 or more than higher than that the value will be equivalent to 0. அதே இந்த கேஸ் ஆஃப் velocity பாத்தீங்கன்னா அதாவது டைப் 0க்கு infinity, டைப் 1க்கு வந்து என்ன பண்றோம் அப்படின்னா we'll be getting the value of which is equivalent to constant value. For the type 2 or more than that, what will be getting over on it? It will be equivalent to 0. சரியா? Next வந்து பாத்தீங்க அப்படின்னா steady state error of the system for parabolic input. அடுத்த input வந்து KA acceleration. ஓகேவா? So parabolicனா என்ன தெரியும் உங்களுக்கு? AT squared by 2. AT squared by 2. A by 2 will be the cancel. அப்ப T squared will be getting off and 2 divided by S power 3. 2 and 2 will be getting cancelled. அப்ப 1 by S cube தான் உங்களோட ஆன்சர். இந்த ஆன்சர் எப்படி வந்து தெரியுதா உங்களுக்கு? That is what I said now. Okay, we'll be having of T squared by 2. So T squared by 2 பண்ணும்போது we'll be getting off and 1 by S cube. Okay வா? அப்ப limit S tends to 0, 1 by limit S tends to 0, S squared into G of S. Okay வா? அப்ப KA acceleration constant வந்து பாத்தீங்கன்னா limit S tends to 0, S squared into G of S. இப்ப நம்ம type 0 apply பண்ணுவோமா? type 0 apply பண்ணீங்கன்னா என்ன வரும்? denominatorல S வரும், மேல numeratorல S squared வரும். கரெக்ட்டா? அப்ப என்ன ஆகும் உங்களுக்கு? So entire term will be 0. மறுபடியும் S power 1 apply பண்ணுங்க. type 1 apply பண்ணுங்க. ஒரு S ஒரு S cancel ஆகும். again என்னவாகும்னா it will be 0. type 2 apply பண்ணீங்கன்னா என்ன ஆகும்? everything will be getting cancelled. You will be getting some constant term. 3 வரும்போது ஆட்டோமேட்டிக்கா என்ன ஆகும் உங்களுக்கு? It will becomes an infinity. அப்ப என்னன்னா இப்ப ஆக்சலரேஷன் வரும்போது டைப் 0 டைப் 1 இது ரெண்டும் எதுல வந்துருது will be getting over on it to be a will be getting to be infinity. Type 2 la வரும்போது constant term வரும். So 3 and higher order system வரும்போது 0 வரும். You can check over now. See over here type 0 the entire system to be 0. Type 1 so we'll have a 0. Type 2 k. Type 3 or higher order system வந்து what will be getting over it will be equivalent to infinity. சரியா? So this is the way to know about an static error constants. Okay. So far any doubt? Nothing. So far any doubt over on it? Because only 6 more slides are there. So if you have any doubt, you can go back and we can check it out. Not that. Okay. This is for your parabolic input. So ESS equivalent to infinity for type 0 and type 1. And for type 2, it is will be equivalent to 1 by k. And for type 3 or higher systems, it will be equivalent to 0. So this is our summary. So this you have to remember it. Okay, wow. So for type 0 system, we'll be giving off an input வந்து step input. Constant value வந்து 1 by 1 plus k இருக்கும். Type 1 க்கு வந்து 0. Okay, wow. Adhe for the case of an ramp pathina type 0 system வந்து will be an infinity. Type 1 will be the constant. Type 2 will be the 0. Adhe madri when you are proceeding for an acceleration input, the thing is to be that we'll be using of an parabolic input value. So for type 0 and type 1 will be infinity and type 2 will be 1 by k. இதுல நீ ஞாபகம் வச்சுக்க வேண்டியது என்ன சொன்னேன்னா positional constant. So in order to differentiate k ங்கிறது என்னன்னு உங்களுக்கு differentiationக்காக you can able to remember kp positional velocity acceleration error kp kv ka. ஓகேவா? So this is about your summary. Okay, இப்போ இதுக்கு சொல்லுங்க பார்க்கலாம். For the system shown in figure below, evaluate the static error constants and find the expected steady state error for the standard step ramp and parabolic inputs. For the system shown in figure below, evaluate the static error constants. So what are all the static error constants? What are all the static error constants? What are all the static error constants? Any one answer? One மட்டும் சொல்லுங்க போதும். What are all the static error constants? ஒரே ஒரு static error constant மட்டும் சொல்லுங்க. What about static error constant? Kp, Ka, Kv. Good. Positional, acceleration, velocity error. Okay, good. So find the steady state error for the standard step ramp and parabolic. Okay, வா அப்ப நீங்க என்ன பண்ணணும்னா உங்களோட இன்புட் இங்க RFS இருக்கு இல்லையா, RFSங்கிறது RFT. ஓகேவா? சோ உங்களோட RFSங்கிறது ஃபர்ஸ்ட் கேஸ் வந்து இன்புட்டா இருக்கும்போது உங்களோட அனாலிசிஸ் எப்படி இருக்கும், அதுவே ரேம்ப் சிக்னலா இருக்கும்போது how will be analysis and parabolic இருக்கும்போது what will be analysis. ஓகேவா? Okay, this is your example. So we know that the value of Kp, we know that the Kp is equivalent to, நம்ம இத பார்த்தோனே சொல்லிருக்கலாமே. What is this type of a system? What type of system it is given? What type of system it is given? Type 0, type 1. Okay, good mala. Type 2 it is given. அப்ப type 2 வா இருக்கும்போது நம்மளோட எந்த steady state error மட்டும் occur ஆகும்? Either it is to be a positional or velocity or to be an acceleration. Kp, Kv, Ka எது வரும் உங்களுக்கு type 2ல எது constant value வரும்? Which will good. Ka will be the constant value. ஏனா lower order systemல என்ன வரும் உங்களுக்கு நம்ம Kp ல வரும்போது obviously it will be equivalent to 0. Ka ல வரும்போது it will be equivalent to 0 and only will be getting about an Ka. Okay வா? இப்ப Kp ஏனா limit s tends to 0 apply பண்றோம். So வெறும் s squared மட்டும் வரும். 0 apply பண்ணும்போது என்ன ஆயிடும் உங்களுக்கு? Denominatorல 0 இருக்கிறதுனால the entire term will be given as an infinity over here. Okay va? Similarly, the next one will be our velocity error constant. So Kv, upper again you have a denominator factor over here. The entire factor upper Kv also will be equivalent to infinity. Next will be goes for Ka, acceleration. So என்ன பண்றோம் நம்ம s squared multiply பண்ணனும். S squared multiply பண்ணும்போது என்ன ஆகும்? This s squared and s squared will be getting cancelled. We'll be replacing s is equal to 0. அப்ப என்ன ஆகும்? 100 into 2 into 5 divided by 8 into 12. Okay va? Appa what will be getting over here? This is to be our 10.4. This is to be our acceleration error constant. Okay va? Appa nama enna calculate பண்ணனும்? We have to calculate our not only our static error constant, we have to calculate expected steady state error also. So steady state error ங்கிறது என்னது உங்களுக்கு? ESS ங்கிறது என்னது உங்களுக்கு? 1 by 1 plus Kp, which is equivalent to 0. ESS equivalent to 1 by Kb, which is equivalent to 0. 1 by Ka, upper which is equivalent to 0.09. Okay va? So these are all about what are all the things that we have seen over here abina. About your what about your control system? What are all the types of your control system? Okay, and then what about your block diagram reduction and signal flow graph? And then we'll be seeing about your signal flow graph, how to determine the transfer function, and what about the transient and steady state analysis of LTI control system and your frequency response. Okay, so this is overall thing what we have seen over here. But I don't know how far you will be responding. யாராவது ஒருத்தர் ரெஸ்பான்ஸ் பண்ணா கூட ஓகே. Any idea about that? What is the Laplace transform of a step function? What is the Laplace transform of a step function? What is the Laplace transform of a step function? What is the Laplace transform of a step function? Step functions சொன்னேனே உங்களுக்கு. What is the Laplace transform of step function? Can't you able to remember it? 1 by s unit step function என்ன சொன்ன உங்களுக்கு? 1 by s. So அது வந்து it is to be our okay. Can you யாராவது ஒருத்தர் ஒரு 10 minutes மட்டும் நான் கேக்குற क्वेश्चनக்கு just you answer over here on chat box. ரெண்டு பேர் ஆன்சர் பண்றீங்களே, விக்ரம் பாஸ்கரும் மலர் and சண்முக ராஜேஷ். So just you try it whether it is to be right or wrong. A Laplace transform method of solution is applicable to equations. என்னென்ன equations பண்றேன்னு சொல்லி பாருங்க. It is to be applicable for differential terms. It can be applicable for integral terms. It can be applicable for scalar terms or none of the above. A Laplace transform method of solution is applicable to equations. என்னென்ன equations பார்க்கலாம் பாருங்க. Differential terms, you can answer me either A, B, C or D. Okay, that is, it can be applicable only for differential terms, or it can be applicable for integral terms, or it can be applicable for scalar terms, or none of the above. Please answer me A, B, C or D. Just to give the response, A, B, C or D. Good, but what என்னன்னா லாப்லாஸ் டிரான்ஸ்ஃபார்ம் வந்து டிஃபரன்ஷியல் இன்டெக்ரல் டேர்ம்ஸ் மட்டும் கிடையாது. Actually, it is applicable only for scalar terms, mother. So it will be answer one. Its answer is given here to be your C. Actually, thank you for your response. Okay. Transient in the systems. Transient in the systems are undamped, unstable, critically damped, overdamped. Yeah, transient in the systems which are to be undamped, unstable, critically damped, overdamped. உங்களோட transient ஞாபகம் இருக்கா? செட்ல அதாவது ஈக்குலிபிரியம் பொசிஷன்ல இருந்து will be changing over settling time. So அது என்ன சிஸ்டம் மாதிரி வரும்? Undamped, underdamped, overdamped ஞாபகம் இருக்கு இல்லையா உங்களுக்கு? Based upon your time, based upon your damping ratio. So for any answer over on it? What about your transient in the system? Transient in the systems which is to be your overdamped. Okay. Thank you so much for your response. So உங்களோட சிமிலர் வே பாத்தீங்கன்னா அப்படின்னா உங்களோட இந்த பிளாக் டயக்ராம் இல்ல ஆர்சி சர்க்கியூட்ஸ் இல்ல வந்து ஒரு க்ளோஸ் லூப் ட்ரான்ஸ்ஃபர் ஃபங்க்ஷன் கொடுத்து இல்ல in order to find your damping frequency, in order to find your damping ratio இல்ல undamped natural frequencies இல்ல ஒரு இம்பல்ஸ் ரெஸ்பான்ஸ் சிக்னல் கொடுத்து அதுல எப்படி நீங்க கண்டுபிடிக்க முடியும், அதே மாதிரி ஒரு கேரக்டரிஸ்டிக் ஈக்குவேஷன்ஸ் என்ன, இந்த மாதிரி தான் உங்களோட क्वेश्चंस இருக்கும் உங்களுக்கு. Okay, ma'am. So I don't know how far y'all refer the question. So it will be the last question. The damping ratio of the characteristic equation. The damping ratio of the characteristic equation. So it's saying s squared plus 4s plus 16. S squared plus 4s plus 16. இது வந்து characteristic equation. ஓகேவா? அப்ப நீங்க எப்படி ஈக்குவேட் பண்ணுவீங்க? s squared plus 2 tau omega ns plus omega n squared. S squared plus 2 tau omega ns plus omega n squared. அப்ப omega n ஓட வேல்யூ என்ன இதுல இருந்து? What is the value of omega n? 4. Okay, good. அப்ப 2 tau omega n அப்ப omega n 4 ஆயிடுச்சு. 2 tau omega n-ங்கிறது 4. So what is the value of tau? 2 tau omega n-ங்கிறது 4. 2 tau omega n-ங்கிறது 4. What is the value of tau? tau omega n-ங்கிறது 4. சண்முக ராஜேஸ்வரன் omega n 4. அப்ப இதுவும் கேன்சல் ஆயிடும் உங்களுக்கு. அப்ப 2 tauங்கிறது 1 வரும். tauங்கிறது 1/2. 1/2ங்கிறது 0.5. நீங்க ஒரே ஒரு விஷயம் ஞாபகம் வச்சுக்கோங்க. tau வந்து maximum it will be equivalent to 1 or it will be less than 1 and it will be greater than 1 வரும்போது அப்ப இங்க வேல்யூ வந்து பாத்தீங்கன்னா 2 tau is equivalent to 1. அப்ப tau is equivalent to 1/2 which is to be your 0.5. So which is to be less than 1, it can be named as an underdamped system. Okay. So thank you all. So Suresh.
Ma'am. Hello, ma'am. Have you finished, ma'am?
Yes, sir. I completed.
Okay, ma'am. Okay. Shall we wind up, ma'am?
Yes, sir.
Okay. Thank you, ma'am. Thank you for your wonderful session on digital control systems, ma'am. Control systems. And on behalf of Fxec Aicte Engineering College, we thank you, ma'am. Special thanks to you, ma'am. Thank you, ma'am. Thank you.
Yes, thank you, sir.
Thank you, students. Thank you for your patience and listening. Thank you, one and all. Thank you, ma'am.
Thank you. Thank you. Thank you, sir.